All right, it should be live. I think. Can anyone confirm?
Not yet.
Oh, I got a URL.
There you are. You're live.
So there's the URL to it in Google+. Plus.
So I guess we got it to go.
Okay, I think we're live. I think we had a lot of noise from Phil there. I've muted you, Phil Plate. All right, cool. Well, let's get started. We got 42 viewers, so why don't we just get cranking. So, hi, everybody. My name is Fraser Cain. I am the publisher of Universe Today, and tonight we've got a very special live coverage from for the NASA MSL Curiosity rover landing, which is going to be happening in about 2.5 hours. We put together a very special group of super space friends today. So I'm going to run through all of the people that we have involved because it's quite a crowd of people. So, so on location, I think this is very cool. We've got, and I'm going to do this in no specific order. So we've got Amy Shira Teitel, who's at NASA JPL, as well as Scott Lewis, who has gone on location. So we've got them. Emily Lakdawala is also in location. Now she's in the main press area, while Amy and Scott are in the trailer, the media.
The cool kids room.
The cool kids room, that's what we're calling it. That's
we're
right.
At the kids table.
The ghetto.
And of course, we've got Dr. Phil Plate, who is at I guess, in Boulder, Colorado, and we've got Dr. Pamela Gay, who is in Edwardsville. We've got Jason Major. I don't know where you are, Jason. Somewhere.
I'm actually in Providence, Rhode Island. Here.
Providence, Rhode Island. All right. Yeah. And we've got the first of many special guests that are going to be happening tonight. We've got Christian Schaller, who is on the Mars Reconnaissance Orbiter team, who is going to be helping with taking photographs of the Curiosity rover as it lands. And then the last participant we've got here in the Hangout is NASA TV, which we have included. We have sort of ensconced and wrapped up NASA TV and included it within our broadcast. So at the appropriate time, I'm hoping we'll be able to sort of hear some of the events that are happening actually live as we get to it. So now for anyone who is wondering, the landing is set for 10:31 p.m. Pacific Daylight Time, which is in about 2.5 hours. That's when it will actually be like wheels on the surface. But before then, there's about 10 minutes or so of 15 minutes of activities that will happen as Mars actually gets towards the surface. So as the Curiosity gets towards the surface of Mars, it's got to go through a whole bunch of things, which Emily is going to be explaining to us very shortly. So we'll be covering all of that as those events are actually happening. Now, when it actually gets to the surface, the hope is that NASA's Mars Odyssey spacecraft is in orbit and will be relaying signals from the rover as it goes down, and that will then be passed back to NASA, and so we'll get more or less live sort of acknowledgement that the rover actually landed and hit and landed gently and softly on the surface of Mars. If that sort of reconnection doesn't happen, if Curiosity isn't able to communicate with Odyssey, then unfortunately the problem is that Mars is actually rotating sort of out of the field of view, and they're not actually going to be able to get any kind of confirmation that the rover survived for another 8 hours for when the spacecraft comes back into rotation. So, sorry, for when the planet comes back into rotation. So that's the. So I'm hoping we'll be able to give confirmation that it actually made it to the surface. If this hookup doesn't happen, then we won't be able to provide that confirmation, and we'll just give you another 90 minutes of pointless speculation. So I think that's our plan for the coverage tonight.
It won't be entirely pointless.
No, I'm just saying.
You make good points.
I'm saying that we will have no way to know for sure what's happened. So
the frustrating thing about this is Mars Reconnaissance Orbiter and Mars Express are both attempting to replicate the fabulous image that was taken of the Mars Exploration rover landing where they caught the parachute over the crater. Yes. And if they image it, they unfortunately hold on to their images for a little while. So it could be the robots know instantly, and we have no idea until they orbit back around.
So actually, Christian, as our sort of first special guest tonight, can you talk a bit about how you guys are working with the Curiosity folks to be able to capture images of the rover during landing?
Yeah, it's really quite a feat of engineering. We've got, we know the path that MSL should be taking through Mars's atmosphere, and MRO will naturally be in the vicinity with our Electra relay antenna, which is going to be capturing telemetry for later transmission back to Earth. And since we're already going to be there, it's, well, I don't want to say it's going to be easy, but it's capable that we can actually take an image of this happening. And to do that, we have to slew MRO across the track of MSL's path through the atmosphere. And we kind of have to get those two vectors to hit at just the right time. So we have to have high-rise pointing at MSL just as MSL, reaches that right spot in the atmosphere. So hopefully we'll get it. The goal is to get it with the parachute deployed, and I believe the estimate is that if we get it, the parachute will be 50 pixels across in our field of view. So that'll be quite a bit bigger than when we caught Phoenix descending. Oh, and if we get it, we should have the images out for the press conference tomorrow morning, I think at 9 o'clock a.m. I don't know if that's East Coast or our time here in the Pacific time zone.
I mean, the picture that happened with the previous landing was really dramatic. It was quite amazing.
Yeah.
Was that luck, or was that exactly what you had planned?
Yes, to all of those. That's exactly what we had hoped for. And there's a little bit of luck involved in the traverse through the atmosphere. But also there's an awful lot of really smart people who know what they're doing. In that case, it was the Phoenix navigation team and the MRO navigation team. In this case, it's going to be the MSL nav team and the MRO nav team and the MRO flight engineering team. Kind of putting all these things together to get just this one right time to hit this. Yeah, and we've been going over the timing for this for the past couple of weeks now, and revising it as we get updated orbit information about MSL.
Right, and so look at this picture here. You can see
There it is.
the parachute and the spacecraft hanging just in the bottom left-hand corner there.
Yeah.
Just an absolutely stunning.
Yeah, I agree. That's probably one of my favorite pictures we've taken. Yeah.
Fraser, can you get that picture up on the screen?
Yeah,
Sure.
I've got it.
Great.
Yep.
Yeah,
And so what we get tonight in 2.5 hours should be even bigger than that, 50 pixels across instead of that looks like it's maybe 10 to 20 pixels across.
Now, did you change your methods at all, like learning from experience on the first photograph? No.
Nope. It's exactly the same. Exactly the same technique.
Why mess with perfection?
Yeah. That's of course the problem. Is there's this seemingly impossible task. We've been 100% successful with it so far. So we have very high expectations right now.
Now, let's assume that the rover is going to make it to the ground. Do you guys have plans then to work in conjunction with them to take pictures,
Absolutely.
to help them sort of map out the terrain in real high level of detail? Yeah.
Yep, absolutely. We've already done that for the Gale Crater area. One of the main missions for MRO, of course, is to classify and evaluate potential landing sites. So they submitted, they being MSL, the MSL project, submitted a bunch of candidate landing sites to us, and we spent a lot of time imaging those in detail, and they finally settled down on this one, before launch. I think it was before launch. Maybe they revised it later, but yeah. So we've done an awful lot of imaging of Gale, and once it comes time for MSL to leave Gale and start trekking out, further afield, will definitely be, kind of looking ahead for them to find any hazards that they won't be able to see from the ground. Yeah.
Now, Emily Luchtwala had to leave us, but she said that the Curiosity parachute is going to be the largest ever opened on Mars at 21.5 meters across compared to 16.5 meters for Viking. Spirit and Opportunity were only 14.1. Pathfinder was 12.7. So, and Phoenix was 11.8. So in this case, you've got a much larger parachute that's going to give you a much more, more pixels for you to view. So I think this is going to be fantastic.
Yep.
Great. Well, thank you very much.
Absolutely.
Cool. So, so I thought we'd just talk a bit about Scott and Amy, who are actually on location. What's it like there at JPL today?
Busy.
it's busy and hot.
Yes.
There's a lot of action, a lot of people just kind of running around. Everyone's kind of trying to stake out their spot, stake out the people, and kind of. I went into the main newsroom, and it was just that classic image of 1,000 monkeys on 1,000 typewriters writing. It was just everyone is just clicking on teeny tiny laptops. It was nuts, and we're in quite a calm little overflow space, so it's actually much nicer. But there's a pretty good amount of excitement in the air, I'd say.
I did have to wait to walk because Will.i.am and his entourage was going through. So a little idea of the energy going on. We're having celebrities. I saw Morgan Freeman in the parking lot.
And I just saw Brad Snowder on Google Plus update that Alex Trebek is talking to the NASA social group right now. So there's some interesting people.
Seth MacFarlane is supposed to be there too.
Yeah.
He was at Planet Fest earlier today.
Right, and he's remaking Cosmos with Neil Tyson, so people asking why he's there. He's a big space promoter.
Yeah. And yeah, you guys are in the overflow room. So do you think at one point one of you will try to make your way into the main media room and just show what it looks like there?
I'll rush into that headlong. It's fine.
I mean, it's pretty cramped in there.
There are some pretty angry people in there. If you try to go and sort of pop on the edge of a table just to kind of show the room, you can't be here. I'm going to try to take my computer into the main hall at around 10 o'clock because that's where the press announcements and stuff are. So hopefully we'll get a chance to give you guys a sense of what the atmosphere and the mood is here and let you actually be in there when whatever happens.
Well, the thing that I really wanted to do was to get someone actually into the control room, but we learned pretty quickly that was not going to happen.
There are little signs everywhere saying no media beyond this point, no media beyond this point.
Geez.
So they've corralled us into this little courtyard and the one media room and the one press room. That's it. So I can't go exploring and take you guys with me as much as I'd like to.
Well, have you guys? Who else has been to a big landing or launch event? Phil, you've been to a few, haven't you? Jason, you've been to one. Phil, you were there for Hubble, weren't you? When Hubble took off? He's muted. You're muted, Phil.
Sorry, when I'm typing, I feel like I should be polite. I was not at the Hubble launch, but in 1997, I went to the Discovery launch, the Space Shuttle launch Discovery, which carried the Space Telescope Imaging Spectrograph, which was a camera I worked on, up to the telescope. So that was pretty awesome. We were about 5-6 miles away, and the best part is how the rocket takes off, and it's 25-30 seconds before you hear anything. And so that's really cool. I mean, this thing lights up the sky, and then it's totally silent, except for people going, yay! And when I was 6, I saw Apollo 15 launch. But that was before Twitter. You didn't know that, did you, Amy?
No, I didn't. That's wicked. I showed Fraser this earlier, and I'll bring it out. Since I don't have tons of Mars toys, but I do have the Apollo guidance computer stamped on my scarf.
Whoa!
Awesome.
That's cool in an incredibly geeky way.
Yeah.
Well, that's the thing. We have actually voted that Amy is the biggest space nerd of the entire crew.
Oh.
It is unbelievable the amount of space toys, books, and various paraphernalia that she has.
Yeah.
Yeah. So the fact that she was able to get her into this was was
Hey,
we were able
Fraser?
to get her into JPL to participate in this is great.
Yeah, I'm in nerd heaven. It's last night I tweeted some pictures, and they're not on my computer, else I'd share them. But the Mars party last night was just all kinds of wacky with costumes and glow sticks. It was like a rave with engineers, and I kept hunting down all these engineers, and I think I spent an hour and a half or so drinking with the guys that built and tested the parachutes for Curiosity, and it was fascinating to listen to them just talk, and they didn't dumb it down for me at all. They really taught me what was going on. It was awesome. It was really that was my favorite moment so far.
So Emily, do you think we could get you to give us your big rundown now?
Oh, sure. I'd be
Are
happy
you ready?
to.
I love
ready.
this.
All right.
Hold on a second here. Let's just get this ready here.
While you're doing that, Fraser, I just want to add, according to the simulator, Eye on the Solar System for Curiosity, it just passed 20,000 miles from the surface, so it's actually, it's edging its way down. Now that's American units, I know. 32,000 kilometers for the rest of the planet.
You can switch that, you know.
I cannot get that running on any computer in my house.
I tried to switch it to metric and it froze, so I'm keeping
Oh, really?
Oh,
It doesn't want you to use metric. It wants you to use period.
Were lessons learned with a previous mission?
I know.
Using one or the other, I'm happy. Yeah.
So I'm metric, you can be English, we're good together.
As long as we...
As long as you talk.
Yeah, as long as we keep one measurement for the entire hangout. Otherwise, it might crash or bounce off the atmosphere.
Okay, never mind. So yeah, I'm. Hold on a second. I just need to send Matt a message to tell him to stop Skyping me, and then. Hold on 1 second.
Now, while we're waiting, so if anyone is interested, you can ask us questions. We're actually watching all of the different ways that you can communicate with us. So there's sort of 4 ways that you can communicate tonight. The first is you're watching this live on YouTube, like, for example, WeeMan444444, who just commented. You can post on the YouTube comments. If you're watching this somewhere embedded on the internet and you want to sort of post through Twitter, you can use the hashtag Mars Hangout. You can also post on the event page where we originally scheduled this over on Google+. And finally, you can post your questions on the Google+ page where this video is started. So it's the one that ends with, well, I'm not sure which one it ends with. Anyway, on Google+. So we're going to try and catch that, and you'll be able to. And so if you ask a question in any one of those locations, we'll try and be able to answer the question, and we're trying to incorporate that in. If anyone's got any pictures, any great stories they want to tell us, please let me know. So that would be awesome. All right, Emily, you ready?
I'm ready to go.
Okay, I'm going to give you your cool video to go along with this.
All right.
So what is going to happen tonight, Emily?
All right. Well, you're seeing the cruise stage separating from the aeroshell, which is, of course, the spacecraft that has cocooned Curiosity the entire time. What you see there is 2 heavy tungsten weights that have just been dropped. Those are to unbalance the flying saucer in order to make it tip a little bit forward like this so that the whole saucer actually becomes like a flying wing. It generates lift so that it can actually steer its way through the atmosphere and target more carefully. That's really what makes this, that's one of the 2 main innovations that makes this landing so much more different from previous landings. So right now it's decelerating by just burning, ablating away as it goes through the atmosphere. Mars's atmosphere is very thin, though, so just doing the heat shield is not enough to slow you down in order to land. That's one thing that makes landing on Mars so much harder than either Earth or the Moon, because you only have to do one or the other on Earth or the Moon. You have to do both on Mars. So on Mars,
I can pause this, by the way, Emily, if you feel like you have to talk really, really fast.
Well, I'm good at talking fast.
Let's see how fast you can go through it.
Well, I can give you more detail, though. If
I would love more details, so I'm going to pause this for a second here.
Okay, so anyway, we've decelerated through the atmosphere, shed most of the velocity, but like I said, Mars's atmosphere is only about 1% as thick as Earth, so you can't decelerate all the way with that atmosphere. It does help that Curiosity is going to a lower landing site than most. It's a pretty low elevation, so you do get a lot of depth through the atmosphere in order to be able to land. Now, at about just below Mach 2, Mach 2 is the fastest at which it's safe to deploy this extremely large parachute, the largest one ever flown to Mars. And so it's going to be at about Mach 1.7, they'll deploy that parachute, which is what's happening right here. And for about a minute and a half, I think, there'll be under parachute slowing down in order to get close to the next stage. Now, it's only when they've slowed below Mach 1 that they can drop the heat shield away. That crashes separately. So we're still descending under parachute, still slowing. And here comes the scariest moment. This one always makes my heart stop. It free falls for a second. So you can pause it there for a second because there's a lot going on right here. When it comes out of the aeroshell, they actually have to drop it and let it free fall for a second. And a second isn't that long, but it feels incredibly long in this video because it just falls out. And they have to do that because if they fired up their rockets right away, it would recontact the back shell and might actually, it would crash because it would crash into its own aeroshell. So they free fall. Then the rockets were actually already on before that free fall moment. They are on and powered up to about 1% of their full power. And then after that second, they power up to 100% power. So Phil, you can keep it going now. All right, so we're descending under power under those rockets, and one of the wacky things about this is that all the time they're firing those rockets, the mass of the whole descending spacecraft is rapidly decreasing because they're burning up the fuel that they're carrying to Mars with them. By the time they get extremely close to the surface, they actually have to turn off 4 of their thrusters because otherwise they would be running at such a low level that they would not have enough fuel going through the thrusters. We're looking now through the eye of MARDI. That's the Mars Descent Imager. It's an HD resolution color camera that'll get us HD video of the descent at 4.5 frames per second. You might want to pause it here, Fraser, because this is the part that I think has most people scared. This part of the descent actually happens really slowly. It's only descending toward the surface at about 3/4 of a meter per second. That's half normal human walking speed. And the descent on those ropes actually happens at roughly the same speed. This part is going at a very, very slow speed, unlike all the rest of it, which is going super fast. While they descend, while they're reeling out on the ropes, they'll deploy the landing gear, which is, of course, the wheels of the rover. And they descend very slowly, and Fraser, you can start it up again, going toward the surface. One of the cool things about this method of landing is that it decouples the touchdown on the ground from the sensation of the touchdown on the ground from when you need to turn off your thrusters. So it has several seconds where it can test. It can be really sure that all 6 wheels are on the ground before it cuts those ropes and lets the descent stage fly away. And I wish this animation continued so we could see the little Wile E. Coyote puff of smoke as it hits the ground, but they don't do that. And there she is. She's landed on her wheels. It's afternoon, mid to late afternoon on Gale Crater on Mars. And if we're super lucky, all this time Odyssey has been flying overhead gathering data. The rover should take a picture with the HazCam a couple of minutes after landing. It'll be ready to transmit a couple of minutes after landing. And then hopefully, if we're really lucky, we'll get that picture back while Odyssey is passing over the landing site. If we're not so lucky, it'll be about 2 hours before we get our first picture back, slightly after midnight here, Pasadena time.
Now, I saw in the comment feed that some folks were wondering at exactly what altitude this crazy stuff is happening. So we have the entry to the atmosphere is happening 125 kilometers up. Parachute then gets deployed 11.5 kilometers up, at which point the spacecraft is going 430 meters per second. So that's like more than 4.5 football fields per second. The back shell comes off about 1.5 to 2 kilometers up when it's going 120 meters per second. The rover then separates away from the rocker at just 18.6 meters above the surface. So there's a huge change, and then it's hovering not that high above the surface as it begins to get deployed. So this is kind of radical the way it starts off when it finally hits the surface of the atmosphere, going nearly 6,000 meters per second, nearly 6 kilometers per second. And then it just kind of gradually lowers it down at 0.5 meter per second.
I need to interrupt you, Pamela, to say that June Lockhart has just shown up in the media room here.
Which is hi.
Which is
you have
pretty
no idea
cool.
who I am.
So that's why I'm distracted over here. Sorry.
For those of you who don't know, she played the mother in the original Lost in Space TV series, which was like huge for me when I was a kid. So the reason I'm sitting here right now is at least a little part because of her. That's awesome.
All right. So carry on, Pamela.
Pamela, I know that you said that how fast the descent stage is going to be going, and you have the speed 6,000 meters per second. That's something that is very hard for people to comprehend. They say Superman was faster than a speeding bullet. Well, MSL is coming down 5 times faster than a typical bullet. So it's hard to imagine something like that actually traveling at a speed that you can relate to.
It's a good reference.
This is cross the entire diameter of the planet in a couple of seconds type velocities.
Now, I hate to be a bad host, but Christian, we've got some other people that are going to be coming in here shortly, so we've already extracted what we need from you, so you're free to go if you want.
Sure.
So thank you very much for jumping in, and the fact that you guys are going to be imaging the spacecraft on its landing is just going to be astonishing, and I really hope it all works out.
Yeah,
so
me too.
Thank you once again for joining us tonight.
Yeah, you bet. And let me say again, we should see the image if we get it at the press conference tomorrow morning. And you can always check out the HiRise website, uahighrise.org, to see the latest images. And we'll definitely have images of the rover on the ground once that happens as well.
Is it possible that you'll have pictures before they actually get a signal back from the rover tomorrow?
I don't know. I don't know exactly. That depends on how the Electra relay.
Yeah. Okay. Well, anyway, thank you once again for joining us. I really appreciate it, and we'll definitely be posting your pictures, your successful pictures tomorrow.
Yeah. All right.
All right. Thanks a lot.
Thanks, Christian.
Yeah.
Thanks.
So I'd like to introduce a new participant tonight. We've got Miles O'Brien for PBS and CNN fame.
Hey, Fraser.
Hey, Miles, how's it going?
Good to be here. How are
you? Good, good. You missed the Emily's fantastic explanation of what's going to happen with the landing, but
no, I saw it. It was awesome, and as I said in the piece I did for the NewsHour, it's part Transformer, part Rube Goldberg, and the only question is, when you combine that and add Murphy, what will happen? We'll see. And by the way, June Lockhart, she's one of my favorites. And when you meet June, she knows instantly how old you are by which mom she identifies you with. Whether it's the Lost in Space mom, certain vintage, there was the Petticoat Junction mom, and then of course she was the mom in the original Lassie series. So if you say to her, "Oh, I loved you in Lost in Space," she'll say, "Oh, you're 53." Just like that.
Well, I'm not 53, although I suspect I'm one of the oldest here.
And I'm one of the youngest, and I do remember Lost in Space because it was in reruns when I was a little kid homesick from school.
There's always
I watched it in reruns.
Yeah.
So I think we'll start bringing in some questions here. So once again, if you want to ask any questions of the team, if you're watching this on Twitter, you can use the hashtag MarsHangout. If you're watching this on YouTube, you can just post a question there. If you're watching this on Google+, you can either post a question in the events page where this was originally announced, or just on the regular Google+ page where we're hosting this. So we'll take any and all questions as we try to watch them stream past. So. And there were some questions here. So now, okay, so this is a great one. So Super Neo wants to know, will the landing be live from the onboard camera? Otherwise, are they going to be faking it? So I'm gonna throw this one at Pamela.
I think faking it is kind of the wrong way to put it. They're using what's called a bent pipe communications relay. So the lander, Mars Science Laboratory, is sending its signal up via its UHF antenna to Mars Odyssey, which is basically a communication satellite nowadays. And then the signal from Mars Odyssey, if it picks it up, the catch is it has to be line of sight to pick it up. If it picks it up, it's going to relay it back to Earth, and this is where we're stuck waiting almost 14 minutes for the light to travel, radio light in this case, to travel back to Earth. We're faking nothing. We'll get the signal when we get the signal, and the frustrating part is as we heard earlier, we have two other Mars orbiters, Mars Reconnaissance Orbiter and Mars Express, who can also be picking up this signal, but they're not doing live relays. They hold on to it for a while and then send it back later.
All right. And they got another one, a great one, which was, will the rover... Oh man, they're coming. The questions are coming pretty fast. I forget where I saw it, but the question was, will the rover be going to the wreckage of the crane? And if so, will there be any sort of science value for that?
I think
Emily's the one to answer that.
Yeah. So probably not is the short answer, and the longer version of that is that. The sky crane will still contain some unburned fuel, and so unburned fuel is something that you want to avoid when you're when you have a $2.5 billion spacecraft on the ground. So they will definitely be avoiding the sky crane at all costs. Opportunity actually went to investigate its own heat shield, and we learned a lot about its descent. But that was also a time at which Opportunity started to have a problem with one of its components. I don't remember which one, and it may just have been a coincidence, but I think they're pretty leery of actually going over to any of their hardware. They're going to focus on their geology mission with this rover.
Now, I remember, and Emily, maybe you can correct me if I'm wrong, but part of the decision in designing the sky crane and not putting retro rockets on the rover itself is because of this danger of unused fuel. Yeah, that the idea of carrying unused fuel around the surface was just like a ticking time bomb on Mars that nobody really wants.
Yeah, and you also don't want to carry around all the mass of the descent stage either, so you wanted to separate the two. But yeah, mostly it's because it's an explosive device, and you need to get that thing away from your spacecraft.
There's already nuclear material on there. We don't need more.
But just to say it out loud, they've sufficiently shielded the plutonium that they're using in their thermal engines, many letters engines, such that in the case of a crash, they believe that no radioactive materials will be spilled. It's a very safe radioactive device.
It's been tested against even launch conditions. If there's an explosion in the launch, it's actually been rated to be protected in that environment. So hitting the surface of Mars is not going to be, I keep hearing audio delay, it's not going to be as much of an impact as exploding solid rockets. So it's going to be a lot safer. If that ever happens, worst case scenario, it's not as if plutonium is going to be released into the atmosphere.
Yeah, I spoke to JPL's communications guy who deals exclusively with plutonium and nuclear material in spaceflight today, and I asked him worst case scenario if it does smash. He said nothing's going to happen, so I trust him. You look trustworthy.
So what's the history of sending rovers to the surface of Mars? How is the success rate? Miles, have you done any research into this? Done any articles?
Yeah, well, matter of fact, I have. And by the way, all that plutonium stuff was certified by TEPCO, so don't worry about it at all. In any case, actually the overall success rate is 1 in 3. But when you look at what those missions are, there were several Soviet missions in the 60s. I think the Russians are 0 for about 30 on Mars. And so that kind of cooks the batting average on the low side. At JPL, they're 13 for 18, which is 720 in the Red Planet League. So that is a pretty impressive success rate. They don't like to use that number. They prefer to set the bar lower because it's always good to lower your expectations and say, hey, it's only 1 in 3 chance. It's the Bermuda Triangle of planets. It is risky. It's difficult, and to raise expectations to say that 75% of the time we succeed is something they don't want to do. But these guys, they're good. They are really good.
It's been interesting to watch the lead up into this. It's been somewhat reminiscent of the lead up into the Shoemaker LV-9 impact into Jupiter, where all the people who are training those of us who speak to the media have been lower expectations. We don't know what will happen. Lower expectations. But you can tell on the inside they're like, it's going to be awesome. It's going to be awesome. And I just love this duality of, yeah, the sucker could crash. This is an extraordinarily high-risk mission. This is where the YouTube video 7 Minutes of Terror is so effective. But These are engineers that have a really solid track record from Pathfinder to Mars exploration rovers to Phoenix. And the only thing that they've even marginally been associated with that's had bad luck is Beagle, and really that was the Brits. So we're doing pretty good.
Someone mentioned that NASA TV is live now, but I'm not sure I've got it. I'm not sure. I'm going to keep searching around, so if I lose attention here, I'm going to be trying to search for the right NASA TV feed.
We're currently streaming some data screens.
Is it? Okay, yeah, I'll try and get access to that then.
You can lean over, you can watch it over my shoulder here.
So we've got a new guest has joined us, which is Dave Mosher from Wired.
Hey, can you guys hear me?
Yeah, we can hear you.
Excellent.
So where are you located?
I was going
like
to go to Times Square tonight, but it decided to rain, so I'm in home base here.
Well, the important thing to know is that in New York Times, right, in the main square, they've actually put up the landing on the main feed in Times Square, haven't they, on the big board?
Yeah, Toshiba did that.
Yeah.
Yeah. They set up a partnership, and the landing right around that time. I don't know if it's up now, though. That's a great question. I would love to confirm that, but again, it's pretty gross outside. So.
We're going to need you to brave it, man. We need to see what this looks like.
Well, maybe I could attach the webcam to my bike, and you guys get
ride with the umbrella at the same time. That would be fantastic. Yeah.
Got 4G, we can make it happen. So.
Awesome. So how I know you guys have been covering this quite a bit. So what's the buzz over there?
Actually, Adam Mann and Betsy Mason have been tackling this primarily. I've been kind of lurking in the background, working on a larger feature tied to this particular event that we're going for at the moment, and that is the power source for Curiosity. There's a lot of debate going on about that particular little item. It hasn't really hit too many mainstream publications, maybe NPR and a couple other places a couple of years ago, but the issue hasn't died out, and that is we're running out of stuff to make nuclear batteries. There's maybe 30 kilograms left worldwide that we know of anyway. This is a really unique material, and we're not making it. We're just starting to test, see if we can make it, how much waste we can produce, and how efficient we can be at this. But it's by no means assured. It's going to take half a decade or more to get the first product. And until we have that, NASA's kind of shaking in its boots about where it could go, if it can do another one of a mission like Curiosity's. There's enough to do another Curiosity, but there's a lot of stuff in the queue that they want to do without more of this material. It's going to without more of this stuff, they're really in a bind. So that's kind of what I've been focusing on the past couple months, and even before that. So yeah, to answer your question, Adam Mann and Betsy Mason are primarily tackling the stuff on the Wired side. I've been sort of long-range, big picture view of material exploration.
And actually, the person who followed you at Discovery Space is normally sitting right behind Scott there in the. Oh, there he is. There's Ian O'Neill there behind Scott Lewis there. You can see him there.
There he is. Yeah, I can see this man.
He can't hear you, though.
Okay. Oh, there you go. There we go. There you go.
Dave Mosher, how you doing?
Good. I don't have any paper cutouts. I used to do that when I was at Discovery. I would print out pictures of space things and I would hold them up in front of the camera, but I don't do that anymore.
Oh, you should. That was your trademark.
Yeah, well, I've got actually just started this interesting thing. In addition to Wired, I also freelance for other outlets, and a new thing I'm doing is for Scientific American, and they have a bi-weekly space show right now where they cover the 5 biggest things that happen in space that week. So I'm starting that now, and I'm thinking of bringing it back, the paper cutouts at some point.
Needs to be done. They're epic.
I see someone else I recognize back there.
Robert Perlman is here from collectspace.com. He's behind you.
This is the cool cam.
got a great little corner going right here.
Robert, hi. I haven't seen you in ages.
Yeah, it's been a couple of years.
Yeah, good to see you.
Yeah, Robert and I spent a lot of time next to each other at space shuttle coverage, and he would listen to me chew on vegetables during the space shuttle missions.
Looking good, looking good.
Okay, so we're going to be getting Scott Maxwell here in a second, who is one of the rover drivers. Is that right, Scott?
That's right. He just texted me. He's setting up his computer, and we'll be waiting for him.
Now, is he in behind the line where the journalists aren't allowed to go?
He's somewhere where I'm not able to be.
And so we've had to get him connected in with the internet. So that's really good.
That's right, and I believe his girlfriend, Kim, who's also on the same team, will be joining him too. So we might get a twofer.
Nice. Well, we're running out of screens here, so just you know.
Kim's a geologist, not an engineer. So you get both a scientist and an engineer.
Oh, that's right. She might be joining in on another hangout then. I know that she was wanting to join in with us to share the awesomeness that's going on with MSO.
Have I found the live NASA feed? Is that it?
Yes, you have. You have found the live NASA feed.
So what are they showing on this TV?
All right.
We've got a countdown going on with the Doppler. Oh, that's interesting.
All right, well, I'm going to introduce Scott Maxwell here. So from NASA JPL, we've got Scott Maxwell, a.k.a. the rover driver, and he was the one of the drivers for Opportunity and Spirit, and he's going to be one of the rovers for the Curiosity. And actually, you announced that in our last hangout that we had with you, Scott.
That's right. That was my I had just gotten the news, and I was pleased to be able to announce at that time that I was going to be one of the rover drivers for MSL, and here I am. The whole party starts pretty soon.
Now we've been sort of joking and sad that we're trapped sort of on the other side of the line where the journalists are not allowed to cross. So what's it like over there on the other side?
I am also trapped on the side of the line, kind of away from the cool kids. So frankly, the whole landing process, we're basically just narrating it anyway. It's 14 minutes light time to the rovers, as your audience might know, and a 7-minute process to land. So that means by the time we get our first bit of data back from the rover has actually been alive or dead on the surface for 7 minutes. So even if we do something right away and turn around a command right away, it'll get there, 7 minutes plus another one-way light time, like 21 minutes too late. So all we're really doing is narrating the landing, and in a sense, everybody in the world who's following along has just as good access as we have right here.
And so how will things? Phil's just letting me know we're at 1.5 hours to the cruise stage separation. And Phil, if you can you explain what that is?
Not really. I'm just taking it right off the eyes on the solar system.
I'm sure Scott can tell us.
I was just going to say, who's best qualified for the engineering aspect?
Well, he only drives them. He doesn't build them.
That's right. That's right. They got to get down there safely before I can do anything. So it's a good thing that our EDL team is doing such a great job, and it's going to get it down there safely for me and the rest of my driving team.
But in answer to the question, the cruise stage is the piece of spacecraft that has steered Curiosity all the way to Mars. It carries solar panels to help power it all the way to Mars, and that thing's about to pop off and release the flying saucer for its descent down to the planet.
That's cool. And so I guess that's the part that people don't really understand is this whole delay. Like we're not going to see things live. We're not going to be able to see the actual spacecraft landing, partly because there's this 14-minute delay between the communication time, but then also just so much of it is done after the fact. So how do you see this is going to break down when the rover actually gets there? Can you hear me, Scott?
Oh, I'm sorry. How is it going to break down? I didn't realize that was a question for me.
It's not going to break down, of course. What I mean is how will the event unfold when the rover gets there, how will we know that it made it?
We will get kind of descent data from the rover all the way down. If we're really lucky, they will move Mars Odyssey into a position where Mars Odyssey will be able to provide a kind of bent pipe relay all the way down to the surface. I thought Mars Odyssey, by the way, was already in this position, but I'm told they'll be doing something kind of at the last minute, and we won't know until something like 15 minutes before the landing if that's true. But anyway, if we get really lucky, the rover will be sending data back kind of all the way down to the surface, and Mars Odyssey will be taking that data in with its left hand, and with its right hand it will be streaming it out to Earth. So we'll have what we call a bent pipe kind of all the way down to the surface. So if we get really lucky, we'll be able to narrate that progress kind of all the way down and get a few images and so on from the surface once we land. Keep your fingers crossed. And mostly, like most of you, I will be following along mostly by indirect evidence. So as soon as I see geeks like applauding and cheering, I'll know that things are going well.
Yeah, I have to say it was actually a little frustrating at the press briefing yesterday because people kept on asking, how are we going to know if when this landing was successful? And people were like, dude, you're going to see people celebrating. That's how you're going to know.
It will be trending on Twitter. That's how you'll know.
One of the useful tools to point out that helps with the narration that I think Phil and I both have open is what's called Eyes on the Solar System. This is software that was put together in part by Doug Ellison, who used to be behind unmanned spaceflight. And the software is programmed to allow you to see in real time what a successful Mars Science Laboratory mission is doing. And it's been amazing to sit here and watch as Mars slowly gets bigger and bigger within the field of view. So eyes.nasa.gov.
And I can't for the life of me get that installed on my MacBook. So
yeah.
It requires Java.
So what's going on is we have a kind of room like that's right next to me where there's like one of the rooms at JPL where like a whole bunch of like people who've worked on the mission are kind of gathering in, and I've gone off to a little like quieter kind of side room, but off in the main room we actually have Eyes on the Solar System running up there. So that's one of the tools that we're using to track Curiosity's progress as she lands on Mars.
So what do you, I mean, the question that I'm seeing lots of times here is, what is the main purpose of this mission? What are they going to be looking for when they actually get there?
Well, what's different about this mission is when we landed, to kind of put the story briefly, when we landed Spirit and Opportunity, we wanted Spirit and Opportunity to be the first field geologists on the surface of Mars. So they took along with them a field geologist toolkit, and they had the ability to look at things under a microscope where a geologist would take a hand lens. They had the ability to kind of drill into rocks where geologists would take a rock hammer and so on. And what's different about this rover is we have this rover for the first time as a geochemist. So for the next step that a field geologist would take, having found a while, is a field geologist and take them back to a laboratory and examine those samples using techniques like X-ray diffractography to kind of help understand what the rocks exactly were made of and kind of like where they fit in context and so on. Since we can't yet bring back samples from the surface of Mars, we're doing the next best thing, which is on Curiosity, we're sending the labs. So Curiosity can actually pick up samples and dump them into instrument chambers that are on board the rover and analyze them in the way that a field geologist would do next. The way that I put this from time to time is Curiosity is Spirit and Opportunity with a tongue.
It also has a remarkable laser to zap things with. This may be one of the coolest parts of this mission, where one of the things that chemists learned they could do a long time ago was if you burn something and study the flame, you can see what elements are within the flame. Well, they don't want to light things on fire on Mars. It's kind of difficult to do given the atmospheric composition. So what they're going to do instead is zap things with a laser and look at the moral equivalent of the flame to try and study the composition of the surface.
Right, in one of the earlier press conferences we had here was regarding inspiring kids with this mission. It's like, if you love space and robots and shooting lasers at rocks, this is the mission for you. Which is essentially, that's a huge part of what's going on, and there's so many, there's so much science that can be done with Curiosity, which is amazing. And so, yeah, it's a great way on getting everyone involved, no matter what your interest is. There's something in there for you. Besides, you know, the awesomeness of getting a robot on another planet, which is monumental by any stretch of the imagination. We're bringing a laboratory to a planet instead of trying to pick up rocks and look at them the other way.
I'm fascinated by this laser as well, Pamela. And when I read about it at first, I was curious about it because what they're going to do is when they zap a laser at something, it lights up basically whatever it's hitting, and those things will then give off a characteristic spectrum, a characteristic color. And I really want to find out exactly how it's doing that, because I assume it's going to use some sort of spectral analysis where it breaks up the light into individual colors, and then you can look at this basically this stretched out rainbow, if you want to call it that. And for silicon will be giving off light here, and oxygen here, and the various minerals here and here. And if you do that, you're going to look at it, and suddenly there's going to be this enormous spike where the laser is giving off its color. And I'm curious, do they have to subtract that? Is that just in a place where they don't care because nothing emits there? As soon as I get a chance, I'm going to dig my fingers into this and try to figure out some of the technical details, because that's amazing what you can do with that sort of technology.
And one of the interesting differences between this mission and Mars exploration rovers is on the Mars exploration rovers, they have these two eyeball cameras that allow beautiful stereoscopic images to be taken. Well, with Mars Science Laboratory, there's one eye that's a lens at a fixed zoom level. So imagine if you can do your telephoto in and out on your camera. It doesn't move. It's your standard unmoving lens. And the other one has a massive telephoto, and so it has this ability to have like this squirrely thing going where with one eye it can zoom in on the horizon, and then with the other it sees this wide, beautiful vista, but it does have this in-between points that also allows it to get the normal stereoscopic images.
And so obviously the goal here is to search for life, right?
No. They're not allowed to search for life.
I know. They're not allowed to search for life.
Follow the water, follow the carbon. So what they're trying to do is figure out, is this an environment that at one point could have supported life or can currently support life based on the presence of water, hydrocarbons, methane. They actually don't have any cameras capable of seeing microscopic organisms, and they don't have any of the other abilities that you'd want to have if you were trying to figure out if you had microbes in a sample. So no genetic testing, no looking for things in a microscope. They're looking for carbon, they're looking for water, and they're looking for carbon-based atoms. Finding amino acids would be totally awesome, but they're not going to do much better than that.
But I think it's worth pointing out, Ashwin Vasavada said to me, we are not blind to life, and should they see some sort of fossil that they can resolve, you could answer that big question. Again, this is about expectations, isn't it, as much as anything?
Well, and there's certain limitations on what they're allowed to do. So I'm not going to get into the complexity of funding the search for life. That's something that Jill Tarter can address much better than I can. But it basically boils down to they can't find microscopic life, but macroscopic life they're totally game for, and massive fossils. So you can imagine if there was a flat of microscopic organisms forming some sort of gross carbon-based sludge in the past, that might have caused a cool fossil. That they'd be able to see, but they can't see microscopic fossils.
Yeah, the joking term we use for that on the project is dinosaur bone. We're always hoping we'll find a dinosaur bone.
How do you like your chances of finding a dinosaur bone?
Well, we haven't found one in 8.5 years with the MER mission, so I don't know what our chances are with MSL, but we'll keep our eyes peeled. If we find one, you'll be the first to know.
I thought that was settled with Alan Hill's 84001, wasn't it?
That's still highly debatable.
Yeah.
Oh, you think?
I've lived in Colorado for almost 5 years, and I haven't seen a dinosaur bone here, except by going to the museum, so it's a big place.
There's a great quote that just came up on YouTube. If they find a Martian cat, will curiosity have to kill it?
Being a cat person.
Well, it has a laser.
Categorically.
It's a laser.
Also, I want to point out that curiosity did not kill the cat. Curiosity was framed. It was ignorance that killed the cat.
See, I'd always heard curiosity did kill the cat, but then satisfaction brought him back.
So there's a bunch more questions. And a lot of YouTube comments. YouTube comments.
Hey, Fraser, I saw one I liked, actually.
Was it?
From X-Flare Gun. Oh my gosh, and of course it's scrolled way down. But he's using, as many of us are who have got it working, the Eyes on the Solar System Curiosity Simulator, which is very cool, and it's showing the distance and the velocity, the distance to Mars and the velocity relative to Mars of the space probe. And what X-Flare Gun was asking was, the velocity appears to be increasing. Why is that? Is that just Mars's gravity? And the answer is yes. Yeah. It has been cruising, Curiosity has been cruising away from the Earth, away from the Sun, towards Mars for several months now. And it's actually been slowing down because of the Sun's gravity. But I think it was yesterday, or a little while ago, it passed into what's called the sphere of influence. It got close enough to Mars that Mars's gravity was significantly starting to accelerate the space probe. Now, because I couldn't get it to work in metric units, I have it in English units, but I've noticed that when I saw the question a few minutes ago, Curiosity was moving 9,000 miles per hour relative to Mars. It's already up to 9,051, and just sitting here watching it, it's 9,052. It's increasing a mile an hour every few seconds. So it's accelerating relatively slowly right now, but when it enters the atmosphere of Mars, it will actually be moving at, I believe, 13,000 kilometers per hour. Excuse me. Per hour is correct. It's actually, that's miles per hour. It's going to be 20,000 kilometers per hour, right? Something like that. So it's going to be moving very, very quickly. And we were talking earlier about what it's going to be doing as it's. Emily was talking about the steps it's going to take as it goes toward the surface. Actually, as it's plowing through the atmosphere, it's going to be decelerating hugely. And just a couple of minutes after first entering Mars's atmosphere, it's going to be decelerating at 13 times Earth's gravity. So if you were sitting on Curiosity, you're sitting in that space probe, you would weigh 13 times what you do right now. So it's savagely decelerating and sloughing off all of that velocity it's gained from Mars's gravity. And that's just, step one. Yikes.
So we need to introduce someone who has joined us. We've got Dr. Jill Tarter from the SETI Institute.
Oh, great.
Dr. Tarter, can you hear us okay?
Woohoo!
No, we can't hear you.
Yeah, well, now you should be able to.
All right. Excellent.
Good to see you again, Fraser.
Thank you so much for joining us. You've already been hanging out for 3 hours with the SETI Institute hangout, and now you've jumped into this one as well.
Well, so you got some of my favorite people there. It's really good to be joining you virtually. And I was wondering, if not a dinosaur bone, suppose you methane, suppose you decided that methanogens, then what?
Well, so there you go. So Scott, if you guys find methanogens, what will that do?
Methane first, right? And then there are a couple of other options, but what if it turns out that really is methanogens?
Well, if you're talking about some kind of biological methanogens, that would be tremendous. We would love any sign of life we find. Our term for that on the project is unlimited funding. We'll take it. I don't think anybody. Having said that, I don't think anybody seriously expects to find anything like that. I think that the point of this mission is to search for habitable environments in Mars' distant past. And if we find that, we're going to be a raging success already. So that's okay with us.
But you can jump into this question about whether or not there is methane in the atmosphere. I mean, the observations from Earth are so difficult to do, and you guys are there on the ground and can sniff the atmosphere.
Actually,
well,
sorry, go ahead.
So if they find methane, is there a non-biological scenario that would make it be there?
So I'm not a scientist. I'm an engineer, and questions like this are a little bit beyond my purview. What I've read about it in the trade press and so on, that there are both biological and non-biological explanations for that. And maybe somebody who's a little better versed in the science side of things would want to jump in on this.
Well, this is where we really need someone like Chris McKay, who's done work to try and figure out if the methane is of a geologic origin, if basically Mars is more alive geologically than we currently think it is, what is the chemical ratios that you expect to find? What is the ratio of different isotopes of carbon? Carbon comes in a variety of different types, carbon-12, carbon-14. It all depends on how many neutrons are in the center of the atom. And depending on how long the methane's been around, where it got depleted, we'll see slightly different ratios of these two different atoms. The sun is constantly trying to destroy methane. The fact that we find methane at all means it's being created within the relatively recent past. Now, if it's a biological origin, we'll see a slightly different chemistry. It's unclear, though, if we know enough about what to expect. This is the problem we had with Viking. It's such a different geology, such a different chemistry. It's unclear if we can truly say for certain, okay, these ratios are like this chemistry is out of equilibrium in this way, therefore it must be methanogens. But what we can say is there are indications that it's a lot more complex than it would be if the geology worked the way we expected.
But the great thing is that you're not blind.
Yeah.
I'll note that some of the observations of methane on Mars were a little bit on the edge for me. I read some of the papers and I was looking at them thinking, this isn't as statistically significant a result as I'd like to see. These are observations from the Earth, in some cases, or using orbiting spacecraft in infrared. I think it was orbiting spacecraft. And there are ways you can see methane has a signature that you can determine, and it was a little bit noisy, and it's interesting, and it appeared to be seasonal. It was changing with time, so it was all very interesting. And I'd like to see, some eyes on the ground, getting better data on this. I'm with Jill. I think if we find methane or methane derivative stuff like that, that would be very, very exciting.
Well, when I was with Jill. When I was with Jill in Arecibo a few years ago, we were talking about the search for life, and she wasn't too terribly impressed with the search for what she called pond scum, which is what this is, right? You want somebody who's going to talk back, not pond scum or even fossils of pond scum, right?
Well, but there's this great point that was made by Chris McKay, actually. I just love his theories. He does really neat chemical modeling. And one of the things that he pointed out is if we can find bacterial life on Mars and we can prove that it isn't of an Earth origin, this shows that life arose on two different worlds in our solar system and that life probably arises fairly easily. Now, the problem is Mars was last wet about 3 billion years ago. Life in the single-celled, boring-celled variety first started to arise on Earth 3.8 billion years ago. We know that rocks from Mars have made it to Earth. We assume that Earth-based rocks carrying Earth-based stuff could be on their way and have already made it to Mars. So there's always the worry of cross-contamination. But if we have a way to, in the future, grab a rock, bring it back to Earth, figure out, is this Earth-based life on Mars or is this Mars-based life, it starts to give us a real sense of what's the probability of life arising within our universe.
Yeah, Miles, Pamela's right. The second genesis is such an amazing, if that were to be something that we could show, is an amazing result. And it would mean that Christian de Duve and all of the people that say life is a cosmic imperative are going to be right. But we're a long way from that.
That's a hard thing to prove, though, a second.
Oh, I'm sure his point was going to be really good, but he's totally locked up.
Hey, Fraser, I want to jump in.
For Miles to come back, I would like to challenge because I heard from reliable sources that the Earth is only 6,000 years old.
You and me both.
Science is 6,000 years old.
Can you say that again, Scott?
No.
No,
Fraser, we've hit another milestone. I want to jump in here.
Sure, yeah.
I didn't notice this, but on Twitter, Carson Myers noted on the again using the Eyes on the Solar System simulator. According to that, a few minutes ago, Curiosity passed the orbit of Deimos, which is the outer moon of Mars. It has two moons, Deimos and Phobos. Deimos is about, I'm just looking this up here, 24,000 kilometers, about 15,000 miles from the center of Mars. You have to subtract off Mars's radius. I can't do that in my head. But the point is, Curiosity is now closer than that moon, and it'll be crossing the orbit of Phobos here sometime soon. I'm not exactly sure when, though. I'm trying to find that information right now. But that's very cool. It's in Mars's backyard right now.
That's cool. Yeah, we're 90 minutes or so away from landing now.
Now, Scott, I know that you don't have much time, but you did tell me an interesting story yesterday at Planet Fest about how you became the Mars rover driver and about interesting parallels to a movie that we both enjoy.
Right. So I don't want to say the Mars rover driver. I'm a Mars rover driver. So I'm part of a team, and that team is very important. There's a lot of really smart, really talented people on it, and I'm just one member of that team. But having said that, so this is my own personal path in. I was working on Mars. Working at JPL in 1995 or 96, and somebody came to me and they said, "Do you want to be part of Mars Pathfinder?" And I didn't know what Mars Pathfinder was, so I said no. And now I blame the sales job of the person who came to me and asked me if I wanted to be part of Mars Pathfinder, because if what they'd said to me was, "We're going to take a microwave oven and we're going to strap 6 wheels to it and we're going to drive that around on another planet. Do you want to be part of that?" I would have said yes. But as it was, I didn't know what Mars Pathfinder was, so I said no. And, come 1997, Pathfinder lands and the Sojourner rover rolls off of it, and I just thought that was the coolest thing. I was kicking myself that I could have been a part of that mission, and I wasn't. So a couple years later, Brian Cooper, who is the guy, he's the lead rover driver for MSL, and the guy who was the rover driver for Sojourner, he had written all the software to drive Sojourner around in addition to using that software to drive it. And he wanted to write a bigger, badder version of that software to drive around what would have been Mars 01. So they were going to take the flight spare for Sojourner and fly that to Mars, the Marie Curie. And he asked his friend Jeff Wyzadecki if Jeff wanted to work on it with him, and Jeff was like, "No, I kind of want to work on like the low-level motor control software for this." But I used to work with this guy named Scott Maxwell, and Scott was really good, and I really liked him. And so Brian brought me in for an interview, and this time around, when I was asked if I wanted to work on a project like that, I said yes. So now the interesting part of this, the really interesting part of this was, I'm sure you guys have all seen The Princess Bride, right? And you know that part of The Princess Bride where Wesley is describing his experience with the Dread Pirate Roberts. He's like, the Dread Pirate Roberts would say to him all the time, "Good night, Wesley. Good luck. I really like the work that you've been doing. I'll most likely kill you in the morning." So what I would get from Brian would be the JPL equivalent of that. He would tell me, "I really like the software you're writing. This is really cool stuff. This is great work. But we only have funding for you for a year, and you won't get to do anything cool like drive the rovers." So at first, when I was working with him, he would tell me that like pretty much every day, and then he started telling me that like a few times a week, and then once every month or so, and then like he just kind of stopped saying that, and that's when I knew that my position on the team was secure. So later on, the Mars 01 mission got scrapped, but that got rolled into the Mars Exploration Rover project, and I and everybody else who was working on Mars 01 just kind of like rolled right along with it. So I was able eventually to turn my job writing software to drive rovers around into a job driving rovers around, and that's what I do to this day.
To demonstrate this with my hands and not really.
Which is awesome.
That is awesome. That's great. Thanks a lot. So Scott, you're now free to go at any point that you need to. So I know you're super busy and you've got a lot of people to talk to. So I really appreciate you joining us. Now I think people are going to want to follow you after this. So where can they find out more?
Sure. Well, they can find me under my own name, Scott Maxwell, on Google+, or at Mars Rover Driver on Twitter. That is at Mars Rover Driver. And from time to time, I like kind of tweet out the names and Twitter handles of like some of the other MSL people and rover drivers and so on that I work with. So we'll tweet it. So just kind of follow me there. And if you're not already following some MSL people, I'll be your entry point.
Yeah, and your Twitter feed is wonderful to follow, and you've got lots of great sort of personal stuff and also just stuff about the mission and your experiences, and I think it's just great to read what you write. So I highly recommend anyone who is watching this right now to quickly go and join at Mars. Is it at Mars Rover Driver? Is that right?
At Mars Rover Driver is correct.
Yeah. Yeah, and then I think NASA could definitely could take a lesson from how well you communicate what's going on in the mission. I think it's fantastic. So thanks once again for joining us, man. We really appreciate it. And
Thank
good
you.
luck.
It's a pleasure to be here in such a Gus company, and keep your fingers crossed for us for another hour and a half or so.
Yeah, you let us know if things go sideways.
Yeah, you'll know. Trust me. Good night,
all right, well, thanks a lot.
Thanks a lot, Scott.
So it's worth noting, or at least I think it's worth noting, that Mars Science Laboratory is now at half the altitude above the planet that our geosynchronous satellites are at. So were it coming in for a landing on Earth, we'd be at the point where everyone who operates telecommunication satellites is starting to breathe, and everyone else is starting to fear for their spacecraft.
Now we've got here, I'm pretty sure I've got the live feed from NASA here, so you can see, I'll put it on the big screen here. It looks better on my computer than it does here in the Hangout, which I apologize. But please, I'm not actually listening to it. So if anybody who's watching this note something really exciting happening on the NASA TV feed, please let me know, and we'll try and switch over to that and get some of the audio happening as well. I think I can pull the audio into this. Let's see.
Well, Fraser, a lot of people on Twitter are saying that our Hangout's better than the NASA feed.
Of course.
But
Yeah.
Yeah.
So got some more questions here. Now I'm not sure what your time is like, Dr. Tarter. So if anyone out there has some questions, it would be great to feel free to post them on YouTube, Twitter, on Google+, and we'll pass along those questions. For anyone who doesn't know, can you give just a bit of a background on what you do with the SETI Institute and what your role is?
At the SETI Institute, I'm the Bernard M. Oliver Chair for SETI in the Center for SETI Research. It's one of 3 centers that we have at the SETI Institute. We have the Carl Sagan Center for the Study of Life in the Universe, and many of my colleagues from that center are here tonight, and many of them have a part to play in this Mars exploration. And our 3rd center is the Center for Education and Public Outreach. And we really do appreciate the kind of thing that you're setting up here, Fraser, and this tool that we all hope to use more effectively to be able to communicate with folks out there who are interested in the science that we do. And right outside the door here, there's a crowd that's growing. It's probably going to hit 10,000 before too long. And it's a bit cold here in Northern California, but everybody's out there with great big screens. And they're having a great time, and everybody at the SETI Institute has fingers and toes and every other appendage crossed that we possibly can. We're interested in the question of life in the universe, and Miles, yes, I think I did make a derogatory remark about pond scum, but indeed microbial life in extreme environments and on Mars would be magnificent to get to understand and learn about.
So we got 1 hour to the cruise stage separation for the MSL, and that was from Carson Myers on Twitter. So thank you for keeping us posted on these, because it's hard to stay on top of all of the information coming at me.
You need an avatar who can sit there and read the questions for you.
I kind of do. That's Nancy Atkinson, actually, my editor, is also behind the scenes here. So we've got a pretty big team going on here. We're all right.
So one common question I keep seeing is just how long is this mission going to last? and it should be 2 Earth years on the surface. Now, the reason I say should is that's what it's slated for, that's what it's budgeted for, but the engine it has can actually work significantly longer than that. So should everything go well, over time it will gradually decrease in power. They'll gradually have to turn off instruments to keep it going, but it has the potential to last for more than a decade.
Well, yeah, and look at Spirit and Opportunity and how long their initial plan time was and how Opportunity's still going. It was planned for, what, 90 days? And now it's still going strong years later. So it has, they were talking about earlier on how we're having a presence on the surface of Mars from Opportunity, and now with an added one for the first time ever having an active presence there, which is amazing. On another planet, we're able to go around on different areas, and we can just keep on going forward.
And some people have expressed concern about the fact that this is a $2.5 billion mission. This is not a cheap mission. But the thing is, the amount of time that it's scheduled to work for, when you calculate the number of days of science return that it should have, it's such a long mission that its cost per day on the surface is actually the same predicted cost as the Mars exploration rovers. Now, the Mars exploration rovers have been the little Energizer bunnies that refuse to die, or at least one of them refuses to die. So we can only hope that MSL will have the same long life expectancy, but its cost in terms of planned costs is what we expected from Mars exploration rovers as well.
I just had to pop in because I saw that from the flight director, they cut off the uplink. So now MSL Curiosity is flying autonomously.
Real quick, guys. Per tradition here at JPL, we have nuts. Now we're out, and so we all have peanuts for good luck. Legumes for luck, everybody. So it's been a huge thing going on, especially if you've been following Twitter. You'll be able to see this, that this is what, Ranger 7, which just eating peanuts, and that was just huge tradition. For the success of a mission, they always have peanuts on hand. And so there have been gifts of peanuts all over the place, all over JPL today. So a peanut jar is being passed around the newsroom right now. Just make sure we all have them on hand.
So we've got a couple more people that have joined us. So over in the SETI Institute feed, people have switched places, and now we have Cynthia Phillips. Can you hear Cynthia?
Yeah, hi everyone.
So what's your role with the SETI Institute?
So like Jill said, we have a couple different centers at the SETI Institute, and I'm in the Carl Sagan Center for the Study of Life in the Universe, and I'm a planetary geologist. So I study geologic activity on the surfaces of various planets and satellites in our solar system. I'm also very interested in looking for active geology, so things that are currently taking place, that are changing. And so, of course, Mars is a great place to study. I'm also interested in icy satellites. I'm out in the outer solar system. So earlier today, Seth and I got into a nice little Europa versus Mars debate. So I sometimes like to tease the Mars people that, well, you know, Europa's really a much better place to look for life. But, you know, tonight I'll give Mars its due.
And Pamela, you were the same?
Yeah, Cynthia and I were both summer students out at Kitt Peak back when we were undergraduates. Yeah. She was over at NOAO and I was over at NRAO, and now we meet again in a random hangout.
You can't get rid of people, and I see Barb Cohen on here too, who I went to grad school with, so it's a very small world, clearly.
I was just about to introduce Barbara Cohen. So Barbara Cohen is one of the scientists for Opportunity. Barbara, can you hear us okay?
Yes. Can you hear me?
Sure. So why don't you introduce yourself to everybody?
Hi, I'm Barbara Cohen. I'm on the science team for Spirit and Opportunity. Of course, not so much for Spirit these days, but Opportunity is still with us and still growing strong. And in fact, we're going to have a lot, I and some of the other people, as people on the Opportunity team are transitioning off to go work MSL, we've got to shoulder that responsibility for the next couple months, which we're looking forward to.
That's got to be difficult. You're working on the opportunity science, but now there's all of the really shiny stuff that's happening over on the Curiosity. So how much longer and how much work will you be doing with Opportunity before you move over to Curiosity?
Well, Opportunity actually is in a really cool spot right now. So I don't know if you've been following Opportunity amidst the MSL madness, but Opportunity rolled up to a giant crater, relatively giant, called Endeavour Crater, and came off of the Meridiani Planum, and that Meridiani Planum rock, that sulfate rock that Opportunity has been crossing for 8 years, and rolled into this new kind of terrain, which we think is older and has phyllosilicates, which is one of the goals of Curiosity. So it's kind of a race for kind of having a little friendly internal race. Who's going to get to the phyllosilicates first? You know, go Opportunity, but of course Curiosity is looking for phyllosilicates and sulfates too.
Someone mentioned on YouTube that there just seems to be one reunion after another. I think this is the whole point. It's such a small industry, the space and astronomy, and everybody kind of knows everyone else, and I think often the conventions and the get-togethers are exactly this reunion after reunion. So I apologize in advance that everyone's going to be so fond to see everyone else. It's like a big party. We've gotten everybody here together.
Weddings, funerals, space landings, and launches?
Launches, and now Google Plus Hangouts. Great. So what's Opportunity working on right now then? I mean, you say it's in a really cool spot on Mars. You know, it's already done so much science. So you know, can it retire? Can it rest? You just going to keep working it?
No sleep for Opportunity. Opportunity's got power coming back. We just went through another winter with Opportunity successfully, and we're on the move again. The CRISM instrument on Mars Express has been a real boon. That mission flew after Opportunity and Spirit, but was able to map from orbit for the first time phyllosilicates, or clay minerals, which we think are products of neutral pH water interacting with your basaltic rocks, the normal rocks on the surface of Mars. And we think that happened very early in Mars history. So that's one of the key goals of both Spirit and Opportunity and Curiosity, is to understand how these rocks formed and what conditions they reflected on the planet. So once CRISM told us that there were phyllosilicates over here in Endeavour Crater, we really hightailed it over here to investigate these in situ. So we're very excited to be able to do that. Now, we haven't come across them yet with Opportunity, but we're doing that pretty soon. We're getting there.
Do you see an opportunity to help really start to confirm some of the discoveries and evidence that Opportunity discovered on Mars with what's happening with Curiosity? It's like another set of eyes and a laser.
And a laser, that's right. A freaking laser on its freaking head. It's, yeah, I think one of the really interesting things to me is going to be comparing the sulfates that Opportunity saw and that Spirit saw. We know those two environments were different, the ones that Opportunity saw, the ones that Spirit saw, both water-lane, both creating these kinds of rocks, but in a little bit different way, and to see how the rocks on Mount Sharp were created. So I think it's going to be interesting to see that for the sulfates, and then for these clay minerals as well. If Opportunity can get there and investigate those, and then Curiosity as well, it would be fantastic comparison points.
That's fantastic. So I've just got news that NASA just lost contact with Curiosity, but I think is that expected?
Or a troll?
Or a troll?
Is that the YouTube comment you're talking about?
Yeah, we're 1 hour to, but I know at a certain point, no, it's too early, but there's going to be a point where they're actually going to lose contact when it moves below the horizon, but I think we're still a ways away from that. So we're about an hour away now until entry, which is pretty cool.
Yeah, it's going at 15,000 kilometers per hour and is at an altitude of just under 14,000 kilometers.
And people said that the feed disappeared for a little while. I'm not sure. Is it part of the conspiracy? Did we say things about life on Mars that we weren't supposed to?
Apparently, Curiosity is in the grassy knoll up there. So, hey, I'm curious, Barbara. I know there is a bit of a friendly rivalry between the teams as to which rover will get to the clays first. I'd like to put you on record. Who's going to do it? Is it going to be Opportunity or Curiosity that finds the clays first?
Do I have to go on record? I'm going to say
Yes.
Opportunity.
Really?
And the only reason I'm saying that is Opportunity is in a really good position right now to get there fairly quickly, and we know that Curiosity has about the same driving distance per day, about 100 meters per day, and Curiosity has a couple weeks to get started. They're rolling her out very slowly. They're going to start her cameras up slowly and start her driving up slowly and make sure everything works. And then there's a fair bit of driving to do. So even though they did a good job of shrinking that landing ellipse down to a very narrow landing ellipse, it's still got a little bit of a path to get to Mount Sharp. So I'll put my money on Opportunity. Not very much money, but some.
To back up for a moment.
Start a pool. Why don't we start a pool right now?
$10,000. Mitt Romney's debt.
Barbara, can you explain why clay matters so much?
Sure, yeah. So one of the things that all these rovers are looking for is signs of ancient water on Mars. And we do that by looking at the rocks. And the rocks, when a rock forms, it records the conditions under which it formed. So that's why it makes this ancient record. So when there's water around, it makes characteristic rocks. Like if you go look at a dry lake bed and you see a layer of gypsum there, well, there doesn't have to be a lake there now for you to know that used to be a dry lake bed, because that's how those rocks form. So sulfate minerals that are currently forming on the surface of Mars, we think those form with water, but with acidic conditions, very acid, not huge amounts of water. So kind of the conditions we see on Mars now: cold, not very wet, kind of acidic. In contrast, clay minerals or phyllosilicates are minerals that form in the presence of a fair bit of water, also with a neutral pH. And so the conditions that form that water-lane rock are different from the sulfate rocks. And we think at some point in Mars's history that we went from a more warmer, wetter Mars to the cold, dry, acidic Mars that we see today. And a fair bit of scientific speculation goes on that maybe that's recorded in the transition from phyllosilicates or clay minerals to sulfates. And so those kinds of rocks are very interesting for us to try to unravel the history of Mars. When did it change from phyllosilicates to sulfates? And in Mount Sharp itself, the base layers, the layers at the bottom, are the ones that are the oldest. That's our principle of stratigraphy. The ones that are on the bottom are the oldest, and those are phyllosilicates in Mount Sharp. And as Curiosity climbs, it'll go up into the sulfate layers, which are younger. And so we hope to really be able to see that transition. And it's the same in Opportunity. The younger rocks are sulfates, and the older rocks are phyllosilicates.
And just to put some years on this for people who are tuning in, it's thought that Mars was probably wet roughly 3 billion years ago, and here on Earth we started forming simple-celled organisms about 3.8 billion years ago. So it's neat to think of how these two worlds were evolving and undergoing heavy bombardment and had these very radically different environs from what we see today.
Yeah, it's a good point, and something that I'm personally interested in is putting dates on those transition times. And that's not something that Mars Curiosity can do right now, and it's something that we really need some good absolute dates on these minerals to do. So maybe on some future mission we'll be able to see something like that go.
And this is where we need the Mars.
Sample return would be good too.
Yeah, that's exactly what I was about to say. This is where we need Mars sample return.
Absolutely. There are people who are working on those kinds of instruments for getting absolute dates on other planets. And so there was actually a really nice article in Nature recently that Eric Cain published about some work that's going on at Southwest Research Institute, and also that I'm doing to develop those kinds of in situ instruments. But with some things, trace elements and isotopes and stuff, we can do a much better job on the Earth than we can in situ. But both are good. Both are kind of complementary.
So we've got a couple of other people who are queued to come up. So, Barbara, it's wonderful to have you. At this point, we've been able to grill you, and you're free to stay or go as long as you want. But we release you.
I'm glad to help.
Thank you so much for coming in and explaining your work on Opportunity, though. It's really exciting, and I hope that you're going to win that bet.
Go Clay. We'll be on all night.
Thanks, Barbara. I appreciate it.
All right. So has anyone got any more details? Any more questions we want to try and crack at?
Well, I just tweeted out a little fun fact. Did you know that the holes in the wheels on Curiosity spell out JPL in Morse code?
As it drives along the surface?
No, they're holes cut out. Yes, and as it goes, it will leave a little imprint, JPL in Morse code. That's true. There's a fun fact for you. It's true. I'm telling you.
We believe you.
That's funny, Miles. I just saw that, and I jumped in to share that. So I found a photo of it right here.
Yeah, it's true.
And
and really the interesting backstory to it is the folks at on 3rd Street Southwest in Washington, NASA headquarters, did not like the fact that the JPL logo was on the last rovers, and so they snuck it in Morse code.
Well, there's also a good engineering reason to have the little blocks of something appear on the wheels, if you'd like me to explain that. And that's the Spirit and Opportunity rovers had little boxes that appeared different from the rest of their wheel treads because that's where they were locked down to their landers. MSL's landing on its wheels, so it doesn't need to have that kind of thing. But they wanted something that they could mark exactly one wheel distance along the ground with the rover tracks, and so they needed to put some mark on the wheels that would leave a special mark every wheel diameter as it rolled along the ground. And so they decided to make lemonade from lemons and stuck JPL in there in Morse code.
So we've got a couple of special guests. Sorry to do this, folks. We've got a couple of people who are going to try and get in shortly, and we're kind of full. So I'm going to need some volunteers. Oh, there's Jason. Oh, there we go, Emily. No more, please. Don't leave us. But yeah, so we've got a couple of people. Hopefully, Mike Brown, the Pluto killer, will be joining us in a second. And are there any questions? Okay, so if anyone's watching this, the hashtag is Mars Hangout. You can post your questions on YouTube. You can post any of your questions on Google+. You were able to post questions on the event page, but unfortunately that hit the 500 comment limit and completely filled up. So we're not able to take any more comments there. So if you're watching on the event page and you want to be able to comment, you can just click on the YouTube and watch it on YouTube, and then you can post your questions there. So we're now joined by Mike Brown. Very yellow, Mike
Brown. Very yellow, yes.
I know. I'm feeling very yellow today. I'm sorry.
Where are you?
I'm actually at home. I just flew in from Google headquarters this weekend, just in time to be virtually on Google instead.
What do they have you doing at the? I'm sure you can't tell us.
I can actually. It was nothing to do for Google, but they have every year they have this thing they call the Sci-Fu Camp. It's science camp for adults over the weekend, and we did nothing but sit around and talk about the craziest things that you can imagine. It was fantastic.
Great. So how is everything? So why don't you introduce yourself in case people have no idea who you are?
So I'm Mike Brown. This is what I did all weekend long, because they didn't have any idea who I was. I'm Mike Brown. I'm an astronomer at Caltech, just down the road for where everybody is there at JPL. Although right now I'm just up the road from where everybody is at JPL. I am purely a fan of all this stuff going on Mars. Have no actual participation in it. Mostly I look at things that are much further away in the solar system than these really, 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 really close by things like Mars.
And of course, for people who know, your history is a lot of your work is in the outer solar system, icy objects. So I guess it doesn't relate at all to the work that you do.
No, not even a little bit. But it's interesting living here in Pasadena, where all this happens, and being on the Caltech campus, where all this is happening, and up at JPL. It's the whole city is sort of electric, and it's my friends up there who are biting their fingernails, and it's not just sort of my virtual friends. It's like people who come to dinner at my house and whose daughters I go to water polo games, and it really is personal for the city of Pasadena.
Now, of course, in about 3 more years, we're going to have a whole other hangout when New Horizons gets to Pluto, and then you'll be key in the conversation.
Yeah, then it's actually things that are comfortably far enough away from the Earth that interesting things start to happen. I'm looking forward to that.
I still have no idea why you are so yellow. Like
I don't either.
It looks like you may have a bent peg on your webcam.
Yeah, like it's missing 2 whole colors, I think.
Yeah, you're projecting yellow and red and missing blue, I think.
You're just a ray of sunshine.
Yeah.
Or I'm a ray of
although
anti-sunshine.
sunshine is white.
Let's see. Let me show you blue. Here's what blue looks like.
You're on Io. It's all the sulfur. Or you're looking for sodium. Weren't you looking for sodium out there at some point?
I was actually just spending this weekend looking for magnesium. So maybe that's. See, does that look blue? No. Yeah, you can see blue. There's blue.
Yeah. So it color corrected everything. That's.
It's just me.
Again.
That's just me.
That's who you are. You like a very vibrant house and a really good yellow sheen to yourself. Yeah, no, that sounds good.
Guess that's it.
So just to interject, MSL is in the next couple of minutes going to pass the altitude of Phobos.
Any idea what that altitude is? How close is that?
Phobos is at about 9,400 kilometers, and right now MSL is at 10,700 and descending at 15,600 kilometers per hour. So
is that
soon? It's going by soon.
Is that Phobos' semi-major axis or its distance from the surface?
That's its semi-major axis.
Okay, so that's the orbital radius from the center.
Right.
See, the eyes on the solar system has 2 different numbers. It has distance and it has altitude. And distance, of course, is the center of Mars.
Oh.
Altitude is above the surface. And I keep looking at the wrong one.
Well, it's a few minutes. It's just a few more minutes than I'd predicted. You're right. It should be the distance. So it's at a distance of 13,500 from the center. So when it passes 9,300 kilometers from the center, it'll go past Phobos.
Right. It's about to pass 10,000 kilometers from the surface of Mars.
Yes.
Or, I mean, it will be 10,000 kilometers to the surface of Mars. Let me phrase it that way.
That is very close. Okay. So, Miles, you're saying that the NASA feed is getting pretty gripping at this point? Oh, I've muted you. Sorry.
You need to unmute yourself.
Yeah.
Yeah, I really don't like being muted, Fraser. Come on.
Just to be clear, and to everyone watching, don't take it personally, but I will mute at the drop of a hat.
Yeah, no, I know.
I mute nonstop.
I've learned this. this. You're brutal.
I'm hardcore.
It's kind of interesting. They're kind of going through their final checks, I guess, and they've got good close-ups of all the team. We might want to listen for a minute.
I don't think I'm getting audio from it. I'll mess around with it, but
really, what? Okay, are you getting the clean feed, or are you watching the show?
I'm watching the show. Did you have a link for the clean feed?
Yeah, I sent that to you a little while ago. I'll get it again.
All right. They're 2 separate computers. The problem, but
yeah.
But feel free to entertain Mike Brown while we still have him. Oh, I see it here. It's the Leaf Stream.
So Mike Brown, I got to know. I know Neil Tyson gets booed by 6th graders wherever he goes. and really, you're the one that started it. Are you vilified by youngsters?
I was vilified by youngsters when it all happened, but they've gotten older. So what happens now? I mean, it's an interesting phenomenon. I got hate mail, email from what I was convinced were like kids in 5th or 6th grade at the time it all happened.
Right.
But I don't get those anymore. What I get now are obscene phone calls in my office late at night, and they have the same characteristic. They're always like on a Thursday or a Friday or a Saturday night at like 1 a.m. It's always young-sounding men, and there's always a party going on in the background. So I'm fairly convinced it's like these same 5th or 6th graders are at their first frat party in college, and they have their first beer, and they're thinking, let's call that Mike Brown guy and tell him what we think. And they call me, and they use words that I don't even know what they mean. They're so obscene. You're listed. You're just there in the phone book, and under the. It's my office. It's not that hard to find. My Caltech phone number. Luckily they don't. The nice thing about having the name Mike Brown is that they could never find me in real life because there are a million of us. Right. But they find me.
Yeah.
I'd like to jump in for just a second. User good old Clint on Twitter points out that the distance in the Eyes on the Solar System map is the distance to the landing site, not the center of Mars.
Oh.
I actually cannot find that in the instructions for this very complicated app, but that has the ring of truth to it. But I just wanted to throw that out there for accuracy's sake. So thank you, good old Clint.
So Mike Brown, found any good planets lately, or subplanets?
We did such a thorough search when we looked for the big ones 5 years ago or so that we put ourselves out of business. It was a bad idea on our part to go find all those so quickly that there was nothing else left to find. So the next round of things to be found that are big and interesting are going to be not out there in the Kuiper Belt just beyond Neptune, but in whatever region of space is next out there. So there's a lot of new technology and big telescopes that we need to be developing before we find those guys.
Now the thing is, the New Horizons team is finding smaller chunks of ice out there, and they're desperately searching, trying to find that Kuiper Belt object that has the perfect, and it could be more than one, the perfect orbit to carry it in front of the New Horizons mission to rendezvous after the 2015 Pluto-Charon flyby. And if you want to get involved with that, we're in the process of waiting for more images to come into the Ice Investigators project over at CosmoQuest. And you can help do some of the things that Mike Brown's done in the past and help us find icy blobs in the outer solar system.
It's pretty fun. You should try it out. It's pretty cool.
We're out of images at the moment, though. They're in the process of desperately processing them. So, patience.
It's hard work. The ones that I found are bright and easy, and we looked in the clear region of the sky, and unfortunately Pluto just hanging out in the middle of the Milky Way galaxy, or in the direction of the plane of the Milky Way galaxy. So finding those little ice balls with those horrible contaminating stars in the background is really tough, which is why it's fun.
It is fun.
So we've got Amy now in the main, I guess where not the cool kids are hanging out, in the main press area. So I don't know, Amy, can you give us an idea of what's going on there?
Can you guys hear me? It's super loud in here because they've got the NASA TV like giant one. They're currently showing 7 minutes of terror for the 50th time today. So it's just terror is gone for me. I'm kind of amused by them.
You're gonna have to yell, Amy.
Started. This is where everyone's starting to gather to try to get. This is where they're going to announce the only TV that they're actually going to have the sound coming in from the announcement of whether or not it's landed. So everyone's starting to stake out their little spots and get involved. Much more exciting in here.
Can you pan around so we can see what the room looks like?
I can, and I apologize that it's going to turn into a Blair Witch style thing. So. We've got really cool. I'll show you a Voyager model. It's a Mars Reconnaissance model, and all the people. So you guys see that full-scale Voyager model? Here's what it looks like in here.
20 meters above the surface. You have to lower the below us on its heaven. It's 20 meters long.
Yeah.
And there's gently deposits.
That's really
So
cool.
that's where we get our press conferences at.
So
So when you're
it's,
watching NASA TV for the press conferences, that's where it's actually at.
All right, cool. Well, it is super loud, so I think we're going to mute you now. So
I'll mute me unless I have something pertinent to say, but for now I'll just, make faces.
yeah. All right, cool. So let's go back to Mike Brown. How do you think, is there any connection all whatsoever between the science that's being done with the Curiosity landing and what you guys are going to be doing with, when the New Horizons reaches Pluto? I mean, is there going to be some lessons learned at all? I mean, one's a flyby, one's a landing, one's a rover, one's a, they're different creatures, right?
Yeah, I mean, New Horizons is kind of is a throwback in many ways to things like Voyager that were just the really super duper quick flybys. My worry is that when New Horizons flies by, we're all going to have gotten used to things like Cassini that are in orbit for a decade and rovers that go around for years, and everyone's going to get all excited to suddenly see these images of Pluto and then say, oh wait, that's it? We're done? But I mean, that's, if you're going to go out there that far in the outer solar system, that's really your only choice these days, is to get out there quick, take a quick look, and keep on going. But this is so much more advanced, the stuff that you can do at these really close by places that you can go to multiple times, and you can do things like land and get there in a short amount of time and go back again. And I mean, we always make fun of the Mars people. Like any planet where you can take pictures of your spacecraft from other spacecraft has really got a lot of spacecraft around it. It's a pretty amazing place.
Now I know that that Jill, you guys have some students and interns queued up to ask a bunch of questions, or was that right?
A couple minutes.
Yeah, we actually had a couple of people, and then they stepped away, so we'll get them right back.
Okay, sure. Yep. We can get that in a second. Cool. Now, does anybody, I've been trying to hack this NASA feed. Does anybody have any update on where we're at now? We're about 45 minutes now to touchdown, right? And I guess about 35 minutes to when all of the interesting things start to happen.
Well, cruise stage separation is in 26 minutes. That's pretty interesting.
Yeah.
That'll be
so what's going to be happening then?
The cruise stage will separate.
Thank you so much. All this history in broadcast journalism, and I throw you a T up there, and that's how you receive it. All right.
No, this is
Pamela Gay. Tell us what the cruise. No, go ahead, Mom.
That's okay. No, this is what's been keeping Curiosity going all this time, these past 8 months, and she won't need it anymore. As a matter of fact, she's going to jettison this, and thus begins the process, which is sort of like a transformer, as it takes various shapes, losing, its heat shield, and eventually its back shell with the parachute, and then down the sky crane it goes. It's easy peasy, lemon squeezy, right?
The difference between this and a transformer is transformers kind of conserve their mass, and MSL is just like shedding pieces as it goes. There is a trail of carnage surrounding this mission where it's just dumping bits. And one question that I have to admit I don't know the answer to, and maybe someone else on this Hangout does, that there's going to be a swath of carnage left across Mars of little dropped pieces everywhere. Does anyone know how long the landing ellipse of the random unnecessary bits is?
Boy, that's a good one. Hey,
that is
I know
a great question.
There was some talk that the powered portion, the last piece that moves away, that has the sky crane attached, could itself have landed safely and have performed some science. Do you know much about that?
No.
It's no longer set up to do that, but
no,
beyond that,
it's just going to crash because they figured it was too many landings to keep track of. But Who knows? That would have been kind of cool. I think ultimately, if they have a successful landing, eventually they're going to.
Nope, we lost him again.
They're going to want him.
Another great point wasted.
Pamela, if I may, the difference between this and the Transformers is that this is real.
Right.
Okay?
There you go.
We're dropping a 1-ton rover on Mars. This thing will travel 560 million kilometers and is going to go through this ridiculous descent phase, and if it works, it's going to work for 2 years on the surface of another planet. So there's that, and then there's the Michael Bay movie. So
you know what else is different?
Go ahead.
It's lasers on its head, not on its hand.
Oh, that's true. It says real lasers. Yeah, laserized. All right.
I need a T-shirt of this.
I heard that it just passed the Phobos orbit, by the way, and I need to check this.
So it's at a distance of 10,300 kilometers, an altitude of 7,400 kilometers, and
the major axis 10,000 kilometers, and that's you have to subtract Mars's radius from that. So it should be, yeah, I think that's right. Oh, you don't have to subtract it. So yeah, it's roughly I lost it. It's a major axis. There it is, 9,400 kilometers.
Yeah.
And we are closer than that now?
Yeah. Yeah, we're at an altitude of 7,320 kilometers.
Okay.
Wow.
So just subtract. So we do have to subtract up.
So
I think that's still right.
Boy, this is impressive math in public. You guys are good.
It's a PhD. That's all it trains you for.
Yeah.
Yeah.
I'm the history major. I don't have to do this.
And the funny thing is, converting from kilometers to miles is easy. The problem is, orbits are measured from the distance from the center of an object, whereas the altitude is from the surface. So you have to know the radius of the object, subtract that on the fly, and then do the calculus and the Glavin, and then you see that even to the simplest person, it's possible to calculate how far this is. But wow, it's hard to do that on the fly.
You're hurting my head.
All right, so we got questions from the SETI Institute. They've pulled their people back here, and we're ready to tackle their questions. SETI Institute, go.
No math, though.
No math. Yeah, we won't take any math questions. Introduce yourselves. Who are you people?
All right, so my name is Heather Chilton. I'm one of the interns here for the summer, working on the dark streaks on Mars under Cynthia Phillips, who was on a little bit earlier. I guess that's my short little spiel.
I'm Alex Baldwin. I'm working with Jerry Harp, and I am fixing up old code and writing new code for the analysis of blazars.
So he's a galaxy guy is what that means. Blazars are galaxies that have actively feeding black holes in their centers.
You missed the important part. I'm writing code. I'm not
so he's a programmer.
Work it.
I write code.
Total galaxy guy. But you got some questions for the team. That's going on your T-shirt now.
Yes.
Okay.
So here's sort of a bit of curiosity on my part. So with this rather unique landing that is going on, what have you heard that are these other sort of unique steps forward in various spacecrafts that you think would actually take place that are just as sort of nerve-wracking and wild as what we're witnessing tonight?
I think for me, it's the Blue Origins and X-Core are both in the process of developing rockets for human beings that take off vertically and then land vertically. And I believe it's one of the X-Core spacecraft that has the fins not like you'd expect them, but they're actually on upside down is the way your brain processes it. And the reason they're on like that is to stabilize the rocket during landing. And so just as MSL is landing using retro rockets and then rope and dangly bits on Mars, we're looking to land on Earth where there's less issues of dust in a very similar using retro rockets kind of way.
And I would say the other one is going to be when New Horizons passes Pluto, they're going to try and be as safe as they can, but there's going to be a sort of cloud of possible ring debris and particles around Pluto that any one of it's moving so fast that if it impacts any one of those particles, it could be a very bad day for the spacecraft. So I know that's of tremendous concern as well. And in fact, the discovery of the recent moon around Pluto, part of that whole process was they were trying to do much better imaging of the environment around Pluto to really well map out any of the particles or any objects that New Horizons might be passing. So that's going to be a nail biter in another 3 years.
But that's what makes all of this so fun. It wouldn't be fun if it all just you knew it was going to work.
Yeah.
Yeah, I gotta say, this spacecraft, there's so many things that have to go right for it to all work out. I feel pretty nervous about it. Like, I know it's going to work. I know it's going to be a big success, but boy, I'm pretty nervous.
Do you any of you guys remember the first time you saw the video of the first lander that bounced? And
that was awesome.
Did you just laugh when you saw it? Like, it's coming down on the parachute and suddenly it goes, and things all come out and it goes bouncy, bouncy, bouncy. And I remember I had the same reaction. I was like, this is ridiculous. This will never work.
It was the Super Ball lander. I actually felt better about that because I understand how airbags work.
And it can. There's a lot of room for slop, and here there's kind of zero room for slop. And and I'll admit, the first time I heard about how this is going, I had the same reaction, which is, this will never work, and I might still have the reaction, but I have my fingers crossed.
Yeah, I mean, when New Horizons passes Pluto, it's just going to really be like another day. I mean, they're going to make sure they turn it, but they've already tested all that stuff. So, it's really going to be about gathering all the data. I know that they have to then turn the spacecraft back to even be able to transmit it, right?
Yeah, I mean, most of the flyby happens so quickly, and it's so far away, and the data transmissions are so slow that it has a really big storage for all the images, and then they slowly trickle back over time. So, the sad thing would be is if it hits some little chunk of debris on the way out of the system, and you would think, oh well, but we still got all those great images on the way in, but all those great images are going to die on storage too. So let's hope it doesn't hit anything on the way out there. But there are definitely things there. The fact that the new moon was recently discovered, pretty much. I think you can guarantee yourself that more and more moons will be discovered around there, increasingly small. So they're there.
SETI Institute, did you guys have some more questions for us? Or interesting analysis?
Why everybody's clapping on the TV? Why are they all clapping?
They are.
Adam Maxwell just gave a pep talk to the EDL team, thanking them for all their work. It was good. So everyone in this building was just in on it too. It's starting to get really kind of infectiously exciting in here.
And EDL is entry, descent, and landing.
Oh yeah, sorry. Clarify.
That's really cool.
We are 2 minutes to cruise stage separation.
Still trying to get some audio from the
solar system.
From my NASA. So talk amongst yourselves. I'm going to try and figure out this NASA feed.
I'm highly amused how every mission comes up with their own way of dressing their crew for landing.
You see the peanuts?
Yeah, so this blue is designed for television. If you've ever been on TV, they tell you to wear a light blue shirt.
Wait, my shirt is blue. You can't tell?
No.
I've got blue stripes on. I feel like I fit in.
So Lunar Reconnaissance Orbiter, when they were launching, they actually dressed their crew in Hawaiian shirts. I'm not entirely sure why, but it's the strangest set of pictures I've ever seen. So Emily is saying you can open your peanuts now. Everyone go get peanuts. I feel like I should mute my video and go get peanuts.
Oh, is that what they were doing? They were giving them a special time that they can do this?
Yeah, so you see everyone nomming peanuts now.
Let's see.
It's a really good use of the term nomming, too.
And if anyone wants to recommend a live NASA video feed, one with audio, I'm not sure why, but I'm not getting any audio from the one on YouTube.
You know what, Fraser, go back to the show feed. It seems like it's doing pretty well here. Try that.
So yeah, I'm on nasa.gov/Mars, and it's perfectly fine with audio.
Surly Amy on Twitter just said, "We dare mighty things," and I think that's a great quote for this evening. This is a truly terrifying thing that NASA is attempting to do that goes beyond difficult.
Well, you notice on the peanuts, they shrouded over the planter's logo. And I suppose the term planting is not a good term for you don't want, right? So let's just get rid of that. And no endorsements, of course, for any particular brand of tiny legumes.
Yeah, I don't know. I had audio just like an hour ago. Oh,
it's always the audio, Fraser. You know that.
I'm such a stickler for audio.
Yeah.
So.
And there is a silent John Grunsfeld.
All right, so is everybody as optimistic as Fraser is about the success of this landing?
No. I am absolutely terrified and smiling.
This thing, yeah, you know, I got to say, at least I remember being there in January 2004 on that cold night when Spirit was beach ball bouncing in, and, you know, we had already been through one of those with Pathfinder, but nonetheless, it was, you know, it was a year after we lost Columbia. There was the mood was really scary, but no matter how bad it was, we knew we had another shot with opportunity coming up in a few weeks. This has the feel, to me, of too many eggs in one basket, frankly. Let me just say it like that. $2.5 billion, and, you know, there's a gold medal, and then there's nothing. That's it. That's scary stuff.
And it's particularly relevant, again, living here in Pasadena. I mean, the line around Pasadena is if it crashes into the ground, we should just all turn out the lights in Pasadena and move somewhere else, because the whole city is just going to shrivel up and die. As it really is, it does feel that way here.
Yeah, so I've met someone interesting over here. Kevin from NASA Langley has men on the inside of EDL engineers. He said that if we have any questions to ask the engineers in real time, I can do this to our new friends here. So if anyone has any questions that they want to pose to the engineers,
you need a microphone or talk into your laptop. Get really close to it.
Is that at all? We're going to get a really close shot of my face. I've got someone here who can give us a direct link into mission control if we have questions.
So just to cut in, they're in the process of de-spinning the mission. It's currently rotating at 2 rotations per minute. They have to stop all of its rotation in order for it to have a controlled descent through the atmosphere. So right now, they're firing away and stopping that spin stabilization.
I'm going to see what I can do about audio for her as well. Oh, texting people in mission control if he has any questions. I like text message from mission control. Let's do this.
And we all go quiet.
Hello?
We begin to panic.
Well, Miles scared everybody.
Well, so to throw some numbers onto this. Right now, the majority of NASA's Mars budget is going to the development of the MAVEN mission. But $65 million, which is fully 30% of the 2013 Mars budget, is going to be going to operations of Mars Science Laboratory. This is mostly salaries and relay links and basically how do we get the data back from the mission. Now, this is fully 5.5% of the entire planetary science budget. So MSL is 5.5% of all planetary science. That's a lot of educators, a lot of engineers, a lot of Mars rover drivers. Well, there's not that many of them. But this is a lot of lives tied up in this mission's success. And no one quite knows what happens if it crashes. Does that money get repurposed? Does it go away? And rumors are it goes away.
Well, but even more important, Pamela, is you have this amazing gathering of great minds working together there, and what's to keep them there? If there's no sample return mission or something of that kind of scale, and it has the feel of the end of the line, and in talking to people when I was out there, you get the sense that there not only is there a lot of pressure to land, but there's a lot of pressure to come up with some pretty close to smoking gun type science to get the money flowing once again. And science shouldn't have to operate that way. Of course, every scientist will snicker because all they do is publish and hope to get more funding. But the stakes are so high, and it shouldn't be this way. It's unfortunate that NASA is in this crazy budget problem with Webb and this SLS rocket to nowhere and a space station that they can't afford. And meanwhile, the most successful component, the most inspiring, the kind of thing that really does get kids interested in the STEM issues, which is what happens at JPL, gets a short shrift. That's not right.
So essentially, if we don't get it and we land safely, that's still okay too, even though it's just nerve-wracking.
Fraser found audio. I'm muting Fraser. That's Fraser. Fine.
Don't mute me. Whatever you do. I can mute me.
Okay.
So you guys were just talking about...
No, did you just mute it? No. Oh, Pamela, don't do that again.
Okay.
Hey, everybody, nobody mutes the NASA feed, okay? Okay? All right. Go ahead, Dave.
Yeah, you guys are just talking about what would happen if this mission would fail. And let's look at history here. Mars Climate Orbiter, Mars Polar Lander, and two probes in a row that didn't make it, and yet the Mars program went on. So I'm a little optimistic, even in this budget climate and ridiculousness of...
yeah, you've been attending different meetings than the rest of us. I think the problem is at the Lunar and Planetary Sciences Conference in March, when they were directing a room full of planetary scientists, this is Jim Green, this is John Grunsfeld, they basically canceled Mars. Mars C can't be funded. We are disappointing international treaties because we don't have the funds to keep up the exploration at the rate we've been doing. NASA's budget is lower than it's ever been before, and there are good folks like Alan Stern trying to search for alternatives. Google search India, Gogo, Uwingu. This isn't new. We've been hearing get off of Mars scientists, go study something else for 2 administrators now. And the truth is, it's a big solar system out there, and Mars funding is diminishing. We have MAVEN. We have MAVEN, but beyond that, it's unclear what will happen.
You know, Dave, the big difference is JPL is a bit of a victim of its own success. The science has advanced to a point where the craft inevitably are going to be bigger, more complicated, more expensive. That's why Curiosity is the way it is. In order to advance the science, you need an oven, and you need mass spectrometers, and you need shovels and jackhammers and all these things that make it a 2,000-pound vehicle. And that's why it's $2.5 billion instead of a much smaller Spirit or Opportunity. And so, you know, we could send up a bunch of Spirit and Opportunity class-size vehicles, but are we really going to be advancing the science or simply repeating what Spirit and Opportunity have done? And that's the conundrum that they're in right now, is that we forced ourselves into a point where we sort of have to pay for a sample return mission or get out of the business altogether. And unfortunately, it feels like we're getting out of the business.
There's a good analog that was being said today, that Spirit and OPI were like geologists. The first geologists there with a magnifying glass and a hammer. And now with MSL, they've brought their chemistry kit. And so we're there to actually try to find out and break down everything there. So yeah, there is this big change there where you do have to bring the lab with you.
Okay, I have to interject here. Cool shit is happening. Cool stuff is happening. MSL is at the entry interface now. It's getting ready to start the guided entry phase, and pyro firing cards are now powered on, according to Emily Lakdawala, who's in the heat of everything.
So look, I got audio.
To the 1010 marker.
Woohoo! If we can land a spacecraft on Mars, Fraser can get audio.
Yeah, his audio is free. MSL costs $2.5 billion.
I'll do that. Right. And we can confirm through EHA now that the BCBs are in manual charge mode.
I love the fact that they're showing eyes on the solar system, which is what we're watching at home. Thanks, Ellison, for a great project.
Completed, enabling the pyros commands.
Boy, tip of the hat to the eyes in the solar system, guys. It's really great.
Yeah.
It took me a couple tries to get it to load, so I don't know. If you can't get it, just keep trying.
We're at peak heating, 2,100 degrees Celsius.
We are less than 3,000 miles from the surface. Or wait a minute, Phil, you said it wasn't the surface, it's the center of the planet? Is that it?
Pyroelectronics that are used.
No, I think that was the altitude.
Devices that are going to be used.
It is altitude, okay.
And a lot of the separation events during EDL have been armed.
So I just did this earlier today. I kind of feel like I got to have this experience. I was at the Google this huge holodeck with Google Mars on it, and you got to fly around Mars. And I did this landing in real life, and I felt like I was about to die.
We're now at peak deceleration. It's pulling 12.9 Gs.
You can see that the fluid coming out of that heat rejection system is actually pushing the vehicle a little bit, as expected. So we can confirm that the vent is actually happening.
Boy.
Odyssey Com, Odyssey Mission Manager on EDL Ops.
Looks like Mars Odyssey is in position, too.
This is bad. We have parachute deployment coming up in 1 minute.
EDL Com, this is Dynamics on EDL Ops. Go Dynamics. Is our display configured correctly for you in the MSA? Affirmative. I see it. Waiting for X-Man tones. Very nice picture. We're expecting tone start at 5:13:17 UTC.
How's the volume? Is it okay?
We're under 2 minutes from cruise stage separation.
Good job.
Odyssey Com, Odyssey Mission Manager on EDL Ops. Odyssey Mission Manager, this is EDL Ops on EDL Ops. Odyssey has completed its salute of the EDL Com attitude. All systems are nominal. Odyssey is go for EDL Com support. Great to hear from you. Thank you very much.
So that's entry, descent, and landing communications support. We will be finding out in about 14 minutes if things like the parachute and heat shield separation went A-OK.
We're about 1 minute to cruise stage separation.
Tones. We're seeing the transition to tones now. The system should be configured shortly. And we're seeing carrier only.
The vehicle's changing to tones at this time. So we're switching from telemetry, we've lost telemetry, and we're going to move to just...
it might be worth, Pamela, reminding people where Curiosity really is at this moment, not Earth receive time. It's pretty close to landing, right?
Right. So it's currently in real world. It's at 1810 kilometers. This is still significantly higher than, say, the Hubble Space Telescope orbit. But It's actually starting right now to begin using its landing radar to figure out how to maneuver its way through the atmosphere. Unfortunately, it about the same time enters Earth occultation. So at that point, it will be unavailable, which is kind of frustrating. But at 10:16, that's when they fire the prime Mars landing engines. And then 14 minutes later, so we're about to fire those engines, and here's where it gets very real. They're going to start out with firing 8 engines, cut back to 4 engines. Now, the reason they do that is because when they power back the engines, they get upset. So they can only power them down so far. So it's easier to shut off 4 than to power them back all the way to where they need to get. Otherwise, so they initially fire the engines to slow themselves down. They slow themselves down enough. And if they keep firing, they'll start to rise back up, which is counterproductive. So they turn off 4, they keep a controlled descent at that point.
The first action it'll take is to fire some warm-up pulses to get the entry RCS thrusters going.
They're describing.
The pulses will ensure the spacecraft will get the thrust that we want, then starts when it's counting on it.
We did see the heartbeat signal drop low for a second as the signal passed by the donut of the cruise stage.
So we're now at back shell separation. In 14 minutes, we will hear, hopefully if it worked or not, Mars Odyssey is currently in position.
I'm sorry, so confirming Mars Odyssey will be able to perform a little bend peg for us, so we have...
Currently, yes.
Great.
We are seeing RCS warm-up.
I'll note that it's now 11:17 on Mars, one way or another. Curiosity is down, but that signal's going to take 14 minutes to reach us.
We'd be within a voice seen long way data on the station.
Hey, did you copy?
Curiosity is reporting that it is spinning down and turning to entry.
Flight HS, we've been one way for a while now.
Roger that.
But currently we're just seeing the tones, obviously. Roger.
So that's step 1 confirmed with the spin down.
Needed its turn to entry and spin down, and it has separated the cruise balance mass devices.
Nice.
Boy, they should be careful about applauding prematurely, huh?
They're applauding every major step.
Okay, good. As long as they consistently do that.
At this time, the vehicle's just sending heartbeat tones, just as we expect. It should be quiet for the next several minutes, hopefully. We are about 7 minutes to entry. At this time, Mars is actually pulling Curiosity in, and we're speeding up. We should be traveling around 5.4 kilometers per second on our way to about 5.9.
It's worth pointing out that it's still speeding up. You got to hit the gas before you hit the brakes. It's kind of like a New York cabbie.
So, Rob, what are your thoughts at this point?
Well, I'm very
variation in the pattern, antenna pattern is reflected in the variation.
This is the part that really is entry. This is where we're going to be at the top of the atmosphere. The great thing is that the propulsion system's shown to be working. We're turning the vehicle. It looks like the vehicle is going to be doing its entry job very well, and I'm very excited about that. Everything is going very well.
Right.
So make sure everyone keeps their eyes on the television, because we might actually get some pictures, if all goes well, and we might be murky and covered with dust when we first land. But we might get some pictures today.
Wow. At landing.
Just a few minutes after landing.
Excellent. Okay, we're standing by.
Thank you.
Amusing tweet here. I guess this would be the MSL prayer. The Lord is my heat shield. I will turn to entry. He guides me through S-curves and pops my chute.
We're just under 6 minutes to entry. We're continuing to wait for entry interface. The spacecraft is continuing to send heartbeat tones, telling us that everything is okay and there's nothing significant to report. This is as expected. It should be quiet for a little while, at least.
Wow. I apologize that we're all in stunned silence here, but we are all freaking out. So, you know,
when
join
they
us
say
in nervous anticipation of this.
This is the 7 minutes of terror where the critters either lived or died. It's either cut its umbilical cord or not. And we don't know. And if it lived...
We're now 5 minutes to entry.
That's 5 minutes to entry, information getting back to Earth. The speed of light is annoying.
Curiosity should be up to about 5.5 kilometers per second.
You live in 2 time zones when you work with things that are far away in space. There's the time zone in which something has already happened, and the time zone you occupy where the signal hasn't gotten to you yet. This is the key to relativity. Blame Einstein.
On that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft.
Yeah, now apparently people are saying that the NASA feed is delayed on the NASA website, so...
And that means it's ready to go. And as soon as you start doing
you'll hear screams from Scott.
Yeah, so Scott and Amy are right in the room right now, and they're going to be able to tell us these.
It starts off at the right bank.
They're going to be able to tell us.
Stood up and fled.
And then make another
it really is the quietest
to the landing
on television. So I'm going to keep my mic on and bring it back on here.
Your radio's sticking out, and
can you tell us how long it is to enter interface? I have 3 minutes.
It's 3 minutes.
Okay.
Actually,
so the flyaway that is nominally taken place of the little carrier craft with the 8 engines and in the end only 4 firing, it flew away for about 4 seconons and went a distance of roughly 150 meters before landing in a puff of dust.
D227 runout looks like missed distance of 232 meters. Over.
2, 3. I love how you can see all the engineers fidgeting in there. It's awesome.
I love when people take pictures of screens.
We can expect a brief signal dropout when we switch to the TLJ.
Yeah, I've tweeted a lot of pictures of the screen.
We're off the mark by about 2.3 meters a few seconds ago.
But remember, we won't get that data for a while. It's got to store it and then send it back down here for us to decode. We're still seeing heartbeat tones, so everything's good. The fast should be up to 5.6 kilometers per second.
1 minute 45.
So I'm going to switch to your... Can you get closer to that, Scott? It looks like you've got the more accurate time here.
Do you want me to unmute so you can just hear what they're saying? Because I've got the accurate times.
Yeah, that would be great.
I'll leave it.
They were just showing eyes on the solar system. So according to eyes on the solar system, there's an altitude of 281 kilometers, 75, dropping.
See that? 2 minutes after. There will be no aid or that's just fine. It's just
So I think we're living in the time zone of when the signal gets back to Earth right now.
Affirmative. Vehicles switching to short drop out when that occurs in tone, switching to a tilt switching panel that we use directly.
There are so many silent people in here. It's amazing.
It's the quietest that room's ever been.
It's so quiet. There's so many people, but you could probably hear a pin drop.
There's so much riding on this. The thing that hurts the most is if it fails, it's the early career people who are going to get hurt the most. The students, the postdocs.
10 seconds.
We just saw the signal drop in case we change the time. We're seeing our heat again after the switch. Things are looking good. Got phones back in. Vehicle reports entry interface. At this time, we'll be pressurizing the propulsion system to increase the thrust of the system. So we use that for all maneuvering the atmosphere we're about to do.
So it's the simulation they're showing. They're just starting. The heat shield is starting to burn away. They're just going through the atmospheric reentry. They're waiting for the start of the Odyssey relay.
You're standing by for start of guided entry.
They're standing by for the start of guided entry. Can you hear me better if I repeat it? Is that
no?
Yeah.
I think we can hear it. It's a little. Oh, Pamela wants you to repeat it. Okay.
Yeah. That's all.
We're beginning to feel the atmosphere as we go in here. Vehicles just reported via tone that it has started guided entry.
Started guided entry.
So this is the point where Mars Science Laboratory has, in its little squished diamond-shaped spacecraft, begun to go through the atmosphere, and it has a series of rockets on the top of this diamond-shaped construct that it's firing to direct its landing. This is unique, and it's the reason that there's such a small landing ellipse for this particular spacecraft. In the past, all the other spacecraft that we've landed on Mars have still been rotating at this point and have descended through the atmosphere at whatever rate they descended. This
It's
one's
past peak
directed.
heating. Sorry, I didn't mean to cut you off, Pamela. Sorry.
So that just means that it's now past the 2100 degrees Celsius point in cooling.
So they're processing data from Odyssey, so the relay is working.
That gives us an answer today and not in 8 hours.
Yeah, that's a good thing.
We like that.
We have a connection, but we actually do not have any data yet.
There's a connection, but no data yet, so, you know.
We can expect some intermittent contact at this time as the signal gets increases to expectable levels.
There we go. We have lots. And visualization is updating next year. There you go. This time, you have to use the longer times to control how far it's flying out range, just heading directly to the target. And the range control, air used minus 1.2 points.
It's so quiet in here.
What did they say? What did they say?
It looks like it's heading directly towards the ellipse. It looks like the guided re-entry is working. It seems to be on target. Totally silent.
It's all you, Amy. Keep us in the loop here.
Power on. We're seeing a tone from the lighting here indicating that we have seen heating on the heat shield through the bed beam unit at the time. So that's there. During the setting line days, we're flying almost horizontally like a plane. We're going about Mach 2.4.
It's going about Mach 2.4 right now, so it's still pretty quick. That's just 541 meters per second. That's fast.
Yeah.
So,
We're standing by for straight up flight.
there's some really excitable people giving interviews behind me.
So Mach 2 is twice the speed of sound.
And they're expecting the parachute to deploy just over Mach 1, I think you just said.
It's about 900 miles an hour.
If you're watching Eyes on the Solar System, you can actually see the parachute deploy just occurred, and these stars are starting to get hazed out by the thickening atmosphere.
Kudos to that team. Whoever
Doug
built that, they have just...
There we go. Got the parachute?
Yeah.
There goes the heat shield.
Yeah, the chute's deployed and they're decelerating. And there's a lot of really red-faced engineers smiling on the big screen in here.
Dynamic phase. Come back again with wrist mode dynamics.
This mode is nominal.
That's over to the bird with a velocity correction of 0.4. Now we're going to keep on moving.
Okay, go ahead and run the Emily engine in preparation for power play. We're down to 90 meters per second at an altitude of 6.5 kilometers per second.
They're down to 90 meters a second. That's 0.37 Mach, so that's just lost a lot of speed really quickly.
They still have a lot to lose to land safely.
Yeah.
Their goal is to land at 0.75 meters a second.
We're down to 86 meters per second at an altitude of 4 kilometers per second.
86 meters a second?
We've lost touch with Earth at this time. This is expected. We're continuing on out of this boundary.
They've lost contact with Earth as expected at this point.
Ground dilution equals minus 10.8 years. Vertical velocity of minus 8 yards per 8 meters per light start enabled standing by for back shell separation.
So they're waiting for the back shell to separate right now.
We are in power flight.
They're so the retros on the back shell have fired, so they're in powered flight. They're in powered descent. 50 meters a second.
500 meters altitude.
500 meters from the surface.
Standing by for skytrain. Constant velocity accordion nominal. Altitude error 5.9 meters. We found a nice flat place. We're coming in ready for skytrain. Down to 10 meters per second. 40 meters altitude.
40 meters from the surface.
Skytrain started.
Adam Seltzer's pacing, but it looks like the sky crane has started.
Signal velocity remains strong.
Remember to breathe. If you pass out, you'll miss the landing.
Touchdown!
Touchdown! Can you confirm, Amy, is the rover safely on the surface?
I think this picture might tell you a few things about that.
I think that goes with that thing.
Yeah.
Very cool.
Wow.
I'm gonna go out on a limb and say this is good news. I can't believe it. Unbelievable.
Wow.
I'm gonna do the Walter Cronkite. Wow. 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 Wow is all I can say. That was amazing.
All right, now pictures.
I love the happy dance. There's actually a happy
my
dance
God.
going on. And their happy
Pamela,
dance is like really excited happy dance.
How long before the HazCam thumbnails?
Yes, Miles, you got the right question.
Pamela,
What was that?
how long before we'll see the HazCam thumbnail pictures?
It could be any time.
Really? Okay,
Yeah.
good.
There's nothing covering the HazCams.
Okay, great.
So the reason that we get the HazCam images first is because all around the wheels are little cameras to make sure the wheels don't have bad things happen. What was that, Amy?
They have thumbnails coming down.
Already?
Yeah.
Thumbnail?
So the HazCams are completely open. The beautiful panoramic telephoto lenses are within the head, which is currently bent down to protect it from getting dust. It will unfold, and tomorrow sometime we should see images from the panoramic cameras and the telephoto lenses. But the HazCams, they're completely uncovered. They're ready to send images right now, and hopefully see them right now.
Can you turn it around?
Amy, can you turn your computer around so we can see it?
There it is.
Okay, I'm gonna put it on Twitter if someone can if one of you guys can put it on Twitter.
So they do have an image, a 64 pixel by 64 pixel image from the HazCam.
Come on, it's a race, people. See the first image. Come on.
Oh wait, it's on the NASA.gov mission pages. Oh no, never mind. It's not there yet.
I put it on Twitter.
Yeah, but you should bring it to the Hangout, Amy.
It's on my phone. Hang on.
I'd bring it to the TV, but I'm tethered by Ethernet right now. Wi-Fi keeps going out.
Okay. So here we are. We're going to start. Go ahead. So we have landed. And
there.
And we now have our first image. And we now have our first image.
Before we have our first thumbnail, we got to ask him in it, so you can see the shadow there.
Okay, Amy, you've tweeted that picture. What are we seeing?
Can someone go to like Amy's Twitter feed and see if we can find this picture? I hear she tweeted a picture.
I'm going to put it on Hangout Lower Third.
And there's a great picture that just got posted of everyone in Times Square. Let me see if I can get that.
And it does have a dust cover on it. It covers dust in the air because we just blow dust all over the place.
There we go. All right. So Dave, got us that first picture.
Yeah, it looks like a screenshot of a screenshot.
It looks like it was a picture taken by Amy. Nice, Amy.
Yeah, that's
and this is
perhaps second. That's what I got.
Does anybody know what we're seeing in this?
Oh, wow.
Whoa, so Scott, that's the picture.
Yeah.
Oh.
So you can see the sky, you can see the horizon, you can see differences in color. It looks like you can see the wheel in the bottom.
All right, now Jason.
Definitely seeing the surface there.
Yeah.
And check Ian O'Neill's Twitter in a few seconds, because he just got another great image of one they just processed.
Somebody said 256 images up.
Okay, Jason, I know this is your head hobby. Get processing.
I got the first one here, but
it's a little dark. I need you to work your magic on it.
They're getting another image.
They're getting another image.
Where are these?
The NASA page says they're up, but they're not.
Wow. You know, it might be worth pointing out, if you were there that night when Spirit and Opportunity, on those nights when they landed, they got a lot more pictures very quickly because those missions were designed as 90-day sprint missions. This is not a sprint. This is a full Martian year, 2 Earth years, and it's going to take them quite some time before the real science and the real images start coming in. It'll be a couple of weeks at least. Pamela, give us a rough idea. I'm so happy to be talking about this, of the timeline from here on out now. What happens now?
Well, it depends, of course, on everything working perfectly, but in the next couple of days they're going to be raising up the head, locking it into place, checking out all of the equipment, rolling away, and starting their exploration. So it's going to be happening over the next few days. Hopefully the head will snap into place immediately. That's always the most terrifying next stage. Because, of course, you don't want the head to get locked down because that makes movement difficult. And they, of course, lose all the science instruments on the head.
So
when will we
here's
see
a better
the Descent
image of
movie?
The Descent movie we should be getting tomorrow.
Oh, wow.
Oh, wow. Great. Great.
Look at that. You're seeing the shadow, I'm guessing.
Yeah.
Oh, there's a lot of crying in Mission Control right now.
Yes.
As it should be.
Yeah.
Tears of joy.
very sweet.
This is something some of these people have been working on from the proposal stage to today's landing for a couple of decades. And if it had crashed, they weren't going to have a job tomorrow. So not only is it every ounce of blood, sweat, and tears, but also whether or not they have the next paycheck.
Oh,
and that's a really emotionally complicated thing to deal with.
You got another image, Phil?
No, somebody tweeted one. I think this is legit. I put it up in the chat room if you want to click on it and share it. Let me see who sent that.
I haven't had time to tweet any of these. These are all for you guys. I'll get mine on Twitter next.
Oh, that's a nice picture, yeah.
Oh, wow.
I think that's real. It sure looks like it.
Yeah.
Let's see if I can bring that
It's
up.
a lot bigger than 64 by 64 pixels.
Yeah, it is. Nice.
Let me save that image. I'll take a look at it real quick.
Hey, Pamela?
Yeah.
How long do we have that window from Odyssey?
Did that come up?
I'm not sure.
There you go.
Oh, that's a great picture.
Yeah.
Yeah, I just don't know what the orbital time on this mission is.
Take a look at that. Good picture, Phil.
That one's 737 by 613, which strikes me as being too big, but I just don't know. It sure looks real.
I've been refreshing the first images page of NASA. Nothing showed up there.
Check out our target location.
See if I can screen share this. Here we go.
Amy, Scott, do either of you know how long Odyssey will be in a position to get us back information? The issue that we have to worry about is MSL is sending its information up to Mars Odyssey, which is orbiting around the planet, and eventually Odyssey is going to end up below the horizon, and we won't be able to use it as a relay anymore.
I know when they were discussing earlier that they were going to be trying to take a photo within the first 4 minutes to get it up there. I'm not sure how long Odyssey was going to be in range before it went out of sight.
Okay.
Yeah, Scott, do you have the press kit there? Because I imagine the press kit would have an answer. I don't know off the top of my head.
I didn't see it in the press kit earlier
got drowned
today.
out by cheers, so.
This is just fantastic.
Jason, how did you get the best pictures ever so fast? How do you do this?
Could you clean those up, Jason?
So,
you make them, they're not red enough, I think. Can you make them red?
Yeah.
So Mars Odyssey has a 2-hour orbital period, which means that it should be over the horizon for roughly an hour. I don't remember exactly when it got into position, however. So there's the potential that we'll have a fair amount of time before it goes below the horizon again.
Could be.
This is crazy.
This couldn't have worked out any better. I mean, really, that was amazing. Thank you, Ian, for the play-by-play.
Yeah, there have been a number of emails that have come down.
So it was, what, 8 months, right? It was launched on November 27th of last year, is that right?
November 28th, I think.
Okay, probably UTC. So 8 months, 560 million kilometers. And I'm dying to know how close they got to the center of the landing ellipse.
Right.
It wouldn't surprise me if it's right smack on in the middle. It's just
I mean, it's pretty interesting how tight that landing ellipse was for this mission, and how because of the technology they used to get it down to the surface, they were able to keep it constrained to a very small, very precise landing. They're going to try and get it as close as they can to that mountain. So they got to jump on the mountain so they can start hiking their way up the mountain to really start to look at the layers of sediment on the mountain. So this is, have they given the precise landing position yet?
they're not going to know for a while. They're waiting for
Yeah.
key pieces of information coming on as far as their velocity, as far as knowing for sure that it landed. It's the velocity, and then we'll try to find its position from there.
Well, congratulations to NASA. What an amazing accomplishment. To everyone at JPL, fantastic. What wonderful news. I am so glad.
There's a lot of people breathing easier. One of the comments I saw was someone who thought I was kind of harsh for making these people will be out of a job statement. Well, I unfortunately or fortunately, I love my job, but a lot of my funding comes from missions. And you don't get your check until the mission gets where it needs to get. They hold on to the money and don't release it if the mission doesn't succeed. So it's absolutely terrifying. I've been in the position of not knowing if I'd have a paycheck the next month because I didn't know if LRO was going to work, and that's just scary. So all of these people have a whole lot to be proud of. They beat the curse.
Oh, so apparently we've maxed out all the comments on both Google Plus and on the event page. so the way Google Plus works is they only have a 500 comment limit. So we filled the one on the event page. We filled the one on the Google Plus page. So now if you want to comment, you can comment on Twitter using the hashtag MarsHangout or on YouTube. So you can still comment on YouTube. I think that can go on forever.
Back in 1990, I just hooked up with Hubble right before launch. I was in grad school and I needed a PhD project, and my advisor said, we're doing something on Hubble, and I said, absolutely, I want in. And that thing launched a couple of weeks later, and it was nail-biting and hair-pulling, and it launched, and everything was successful. And then we got the pictures back, right? And Hubble wasn't focused correctly. And then it was 2 years of maddening work trying to get that fixed, or at least trying to deal with that problem. And then over the next few years, it was fixed. And then in 1997, I was actually in Florida for the launch of the shuttle to lift a camera I'd been working on to go into space, and they put it on board Hubble. And we sat there watching this whole thing live, and it worked perfectly. And so, since then, too, I've done education and public outreach on, I'm not even sure how many satellites, 4 or 5 or 6, something like that. And every time they launch, it is gut-churning, horrifying. You cannot stand the tension. The reaction we're seeing in the mission control room, man, you make fun of nerds, you make fun of geeks, they're engineers, they're scientists. You know what? We're humans. We are just as loaded with emotions as anybody else. And to have your entire life invested in a single moment that is out of your control once things are in motion like that is beyond description. And so what we have done here today is the very best of what we can do, the very best.
And they've gone through such a roller coaster of, they had to develop completely new technologies that hadn't been tested before. They went through congressional threats. They went through even the mainstream media. No offense, Miles, I don't think you were involved. Even the mainstream media attacked them for their budget overruns, for being such a high-risk mission. Why are we doing this? And they kept their heads above. They worked with integrity. They did something really amazing. And they knew all along probabilities. It was a coin flip, and it all worked. And it's such an adrenaline release right now. I'm sure they're all going to sleep like babies for 3 days.
Should I mute?
How about burgundy T-shirt meet?
Yeah.
I'm not sure what Phil was doing there.
I was just showing somebody the recording of Carl Sagan's Pale Blue Dot right before this landing. Somebody who's not really informed on science. She's actually in the room right next to me. She's flying out of here tomorrow, but she had never seen that before, and I thought it was really fitting just watching this rover land and succeed. you know, it's on another planet. It's equipped to do some amazing science. And for those who aren't familiar with the pale blue dot, it's this concept that the Earth is this pixel in this vast cosmic arena, and all of our struggles and all of our hatred doesn't really matter. What matters is getting out there and exploring, and I think that's what I'm feeling right now. That's kind of the vibe that's going through my body right now. I don't know about you guys.
I just feel like they're going to let us keep exploring now. We had to prove that this mission was worth the time, was worth the energy. We had to prove we can rise above the challenges and conquer the challenges and land in a little tiny landing ellipse between a crater wall and a mountain. And these guys proved all of it. And this is going to allow us to say to the critics of space exploration, look at what we did. We did something truly terrifying, truly awesome. Where next? Titan, Europa. There's so many awesome places left to explore. And there's so much awesome science that's now going to come out of this mission. There's the search for methane in the atmosphere. There's the search for carbons in the soils. There's the search for clays that formed during epochs in the past that were wet. We don't know what we're going to find, but we know that it's going to be amazing because we've never had the capabilities this mission has. And every time we take a new instrument to a new world, we're able to learn things we never imagined, and it's just a truly amazing future.
You know, we haven't talked much tonight about the connection between this and the piloted space program, but the fact is, if we're ever going to send human beings to Mars, we need to be able to do what just happened tonight, and we need to be able to return a sample to Earth, for example, and we also need to continue the hunt for interesting places for human beings ultimately to go when they do eventually put footprints on Mars. And so, you know, a lot of times the robotic and the piloted community are at odds, but the truth is the two do go hand in hand, and this is all about laying the groundwork. Now, I got to say, Pamela, I can't think of many fields of endeavor where so much work is on the line in such a short period of time. And I often ask people who are involved in your line of work if they go to Las Vegas. And if they go, are they always the all-in bet? Because it's the ultimate riverboat gamble bet. And here you are, you just paid off in spades, and you're still in business. And as you say, if you had failed, you might as well not show up at work tomorrow. How's that for focusing the mind?
It's you have to risk a lot to accomplish a lot, and taking the human race off of the planet Earth is perhaps the greatest thing we can seek to achieve, and it also requires in many ways the greatest risk that we can have. People put their lives in risk every time they leave the surface of our planet. And the first steps are robotic steps. We've shown this over and over as we've gone to the moon and now as we go to Mars. It's robotic steps. And I'm not putting my life at risk by working on NASA missions. I am sometimes putting my paycheck at risk. But the payoff of when these things work, I get to be parts of teams where we're discovering icy objects in the outer parts of the solar system with New Horizons, where we're helping to understand the past history of the moon with Lunar Reconnaissance Orbiter, where we're finally starting to figure out Mercury with the Messenger mission. And I'm not sure we're finally starting to figure out Dawn, but we're starting to figure out what the questions are with Dawn when it comes to the asteroid Vesta. It's huge risk. But because of these risks, we're starting to understand our solar system and understand our place in space. And understanding that place in space is one of the most fundamental questions that people start asking at 2 and keep asking until they're 102.
So just to focus on the mission that's happening right now, although that was awesome, Pamela, is people are wondering about the quality of the images that are coming back from the rover. So why have we got fairly low-res black and white images coming back so far? When are we going to see the big pictures?
The big pictures come when they've unfolded the head, which is a very disturbing thing to say. The rover is basically a box that does act in many ways like a transformer. It has a neck with a box on the top that has 2 high-resolution cameras on it. One has a telephoto lens, the other has a fixed lens. These are the high-resolution cameras that will give us the beautiful vistas. In order to protect these lenses from dust during landing, and in order to just protect this large, ungainly head, the head was tucked under, the entire neck was folded down so that they basically landed a box with 6 wheels. They now need to unfold that neck, unfold that head, and look around. The cameras that we're currently getting images back from are called the hazard cameras. I don't know if we're getting images from more than one of the hazard cameras, but the wheels have little tiny cameras on them so they can see what the wheels are dealing with. These are important cameras for figuring out, is this a rock I can climb over? Why am I stuck in the sand? It's the rover's way of checking where its feet are located.
Miles, you made a point earlier about its robotic and piloted missions in step, or Pamela made that point. And I think one of the things that is so telling was sitting here tonight 14 minutes away from the information. And the point is, if we're going to do real science, we'll probably have to be closer to these robots to teleoperate them than 14 minutes away. It's just too long, and there are too many hazards. So I think it's going to be a human and robotic partnership for exploration.
Well, and you know, Steve Squires is, I forget the time increments, but he frequently talks about how long it takes opportunity to do a particular task. It's a matter of weeks as opposed to just a few minutes if there was a human being there doing the job. So clearly, when we do explore Mars, and I do say it as when, not if, when we do explore Mars, it will be with humans alongside robots. Clearly, that's the way it will happen. So this is, whether we have an official Mars program or not, and we know the answer there's no funding to go to Mars. This is part of laying the groundwork to do just that. We can't get there with human beings without doing what we just saw tonight. So it's a big moment, one to savor.
Some of the first images have been posted onto the NASA site, but they're very small.
They're adorable.
Yeah, I would say they're about 50 pixels tall, 90 pixels wide. Yeah, very small images.
Apropos to what Miles was just saying, through my friend Amanda Bauer, who is AstroPixie on Twitter, she just tweeted saying, retweeting somebody named Mike Hopkin, who said, "Landing on Mars doesn't come cheap. Curiosity's mission budget is a staggering 0.17 London 2012s." And I just looked that up. The Olympics cost over $14 billion. Okay? This cost a fifth of that.
That's incredible.
Okay. Are you serious?
And so look at this, right? As I like to point out all the time, we spend 5 times as much on tobacco products in this country as we do on NASA every year. We spend $90 billion on cigarettes, essentially.
That's a really good statistic.
And look at what we're doing here with a tiny fraction of that money.
Well, there's a similar one for pizza. I think it's like $50 billion on pizza.
Yeah, one of my favorite statistics for NASA is NASA's education budget for 2013 is $100 million. This is for all the K through 12 programs, the summer programs for high school teachers and students, all of that stuff. This includes the type of stuff I do for CosmoQuest. The McDonald's budget for advertising Happy Meals is greater than that. So McDonald's is going to spend more money trying to get kids to eat Happy Meals than NASA is allowed to spend educating minds.
So I think Jason has the best images that we've seen so far.
Yeah.
I'm going to bring those up again.
Yeah, I've got a poll up right here if you want to take a peek.
Yeah.
What are all those speckles?
Sweet.
Is that like dust on the camera? Yeah, around the bottom there. Do you see all that?
Along the rim, yeah.
Yeah.
They'll have the cover are still on them.
Oh, right. The covers were transparent, right? They're not.
Right, but the dust was still attached to it, and then the covers will come off, but they did want them to be transparent so they could get their initial images right when they land.
Where did you get those, Jason?
Well, what I did was I was watching the NASA TV feed, and when they briefly took a shot of that, I had it full screen, so I took a quick screenshot, jumped in there, cropped them out, and dropped them next to each other so they didn't have all the other screen information on there.
It's interesting that they're so large, though. They're supposed to be 64 by 64 pixels.
Yeah, but that's a screenshot, so it's taken a high def screenshot. So I managed to zoom in there a bit.
Right, probably with the upscaling going on with your TV.
There's a little bit of upscaling there and a little bit of sharpening to bring out some detail.
Yeah,
you can actually match them to the one. You can match those images to the ones on the website. They're just in the opposite left to right, right to left order. The one that Jason has on the left is the rightmost one on nasa.gov/mission_pages/yada yada yada. Look in my Twitter feed, and the other one appears to be the second from the left image.
Well, these are going to get a lot better in the next couple of days.
We just need the head to unfold.
Is there not also a capability for 10 frames per second video with Mastcam?
Yes. Yeah, so it's not quite video, it's not quite full blown video, 24 FPS or anything like that, but it's pretty good. It's better than time lapse. Nothing wrong with time lapse. We like time lapse.
Unfortunately, the Jim Cameron camera got nixed, as you know, which it had zoom 3D capability, which would have allowed the capturing of movies, although limited frames, in 3 dimensions. They can do 3D stills because they have a 100mm lens and a 37mm lens. They have to do multiple images in order to get 3D images. But you can't capture movies doing that. So that zoom camera that Jim Cameron had designed and was pushing NASA to put on board, it was a matter of money and just not enough time to get it together. So we'll have to wait for the 3D Mars movie for the next mission. But I think we can say there will be a next mission, which is a good thing.
Well, and it's called Maven. It's already funded. It's already being built. What was that?
What is the next big mission?
Maven is an atmospheric mission.
Yeah, I was talking about a lander.
Okay.
Is that the methane detection mission?
I believe so. I have to admit, I usually don't invest too highly in missions until they've launched, just because I got my heart set on Terrestrial Planet Finder, and then it got canceled.
Indefinite hold.
Indefinite hold. That is true. Now one thing that needs to be pointed out is one of the reasons that they don't have too many video cameras and things like that on these missions is getting the data back is hard. So you have Little Rover on the surface of the planet that does have the ability to send information all the way back to Earth. But it prefers to send it up to Mars Odyssey, Mars Reconnaissance Orbiter, Mars Express, to use one of those 3 missions to use what's called a bent pipeline. Then once that data starts coming back, we have to capture it here on the planet Earth, which means we need to use radio receivers here on Earth. The signal's not that strong, so we have to be using pretty big radio dishes. And that gets expensive quickly. So they can't always get as much data back as they'd like. This is particularly a problem for missions like Cassini, where really the big holdup is how much data can we afford to bring back to Earth.
Raise some small telescopes.
All right. So do you have any more questions? Again, if anyone has any questions for us, you can post with the hashtag Mars Hangout on Twitter, or you can post your questions to YouTube. We've filled up all of the question room on Google+, so unfortunately we can't handle any more questions there. but on YouTube or on Twitter, you can still do it. And we're joined by Sawyer Rosenstein. Sawyer, how's it going?
Good. How are you, Fraser? Good to see you.
Good. So if people don't know, Sawyer does the Talking Space podcast, which is just fantastic, and a great space journalist. So were you watching the coverage with us, watching the NASA feed? How are you getting your mainlining your NASA news?
Well, I had you guys in one ear, NASA TV in the other, and Twitter on the screen. So I definitely kept busy, and I have a feeling it wasn't more of watching it rather than biting off all my fingernails and then probably waking everybody up in the neighborhood once it landed.
Give it a big yell.
Oh yeah, it's one of those where, even though your hands are trembling and you can only imagine the people that are there. If this is the excitement you feel, the people that are at JPL that have worked on this, that have had anything to do with it, the amount of pride that they must have.
You've been to a couple of live events, right? Have you? Which ones have you been to? You went to a launch, didn't you?
I've been to a couple of space shuttle launches as well as SpaceX. I haven't been to an unmanned launch, and unfortunately I didn't get to see Curiosity, but from what I heard, it put on quite a show then, and it put on quite a show again tonight.
Yeah, it's been epic so far. Someone just suggested on YouTube, why doesn't NASA do a Kickstarter? There's actually been a bunch of Kickstarter stuff going on, and Pamela, I believe there's one that's happening right now.
Yeah.
Why don't you talk about Uwingu?
So over at Indiegogo, there is a new project called Uwingu, U-W-I-N-G-U. This is a Swahili word for the sky. Alan Stern, who is a former deputy director of NASA, he used to have the same job that John Grunsfeld currently has. He and many others started trying to figure out how can we generate funding for small science projects and even eventually, hopefully, large science projects for all of those times that NASA funding just isn't there. And so they've developed a bunch of commercial online projects where all of the funds from those products is going to go, well, not all of it, there's overhead, there's server costs and things like that, but the majority of the proceeds from these online products is going to go to fund research, and the people who are involved in these products are going to get to help say, okay, we're going to fund Mars, we're going to fund Titan. You can get involved. The Kickstarter is looking to get all of the funds to turn on the licensing, turn on the servers, and turn on all the stupid legal stuff you have to do before you launch a company. But again, it's Indiegogo. The project is called Uwingu. Uwingu. It's Swahili. I can't pronounce anything. People who listen to this on the cast
Pamela.
Yes.
How are they? I don't get the business model. Explain how this really works.
So I have to admit I'm limited on what I'm allowed to say by non-disclosure agreements.
Okay.
They have a series of really awesome internet-based products. They're basically gamifying space, and people will spend money to get something that's really cool, really fun. I'm not allowed to say. We're doing the whole build up the anticipation, and then when they've bought that thing that's fun, the proceeds from that after overhead is taken out, and it's guaranteed at least 50% of the proceeds is all going to go to research. Researchers will say, look at my track record, here's what I'm hoping to do with the future, and we're going to be working to fund individual researchers.
But I think there's also been, I know there's a few satellites that are looking to get crowdfunding. There's amazing stuff with, like the Google Lunar X Prize. So I think we're not only in a sort of innovative time of space exploration and the kinds of missions that are happening, but also just the ways that people are being able to raise money and put these things together. So it really feels like it's a bit of a logjam with everything kind of going through NASA. So at the same time, NASA's getting defunded, which is terrible, but a lot of other people are starting to pick up the torch as well. So I think we're going to see some pretty exciting new ways that things are going to get funded shortly. So. And
everything for Uwingu is linked off of my blog, which is Starstrider spelled with a Y, because I wasn't thinking the first time I wrote it down. Starstrider spelled with a Y.com.
It's on your little tagline there. So I know that SETI Institute's got to wrap up, and they've been going all day. So again, thank you very much. It's a total honor to have folks here, Dr. Jill Tarter, and I know Seth Shostak was here earlier, and thanks to Shiraz from Google, who's sort of around the corner there. Thanks you so much for joining us. It was wonderful to have you here.
Well, thanks for letting us hang out with you. This has been great. We've been here, for a lot of hours, but it's been a
well,
and Shiraz's fingers are worn to the bone, right? So he's got to stop typing and get some sleep.
Yeah,
Thanks.
well, what a great, it's great that we can have a happy ending to this whole story so far, and now I guess it's all just, the next stage is beginning.
Yeah, well, I think for us the next stage is trying to get out on 101 and get home.
Good luck with that. Wonderful, well, thanks again. We'll see you guys later.
Thanks, Jill.
Good night.
Good night.
Good night.
And if I could actually add to what we were just talking about briefly before, I know NASA at one point, to throw a little bit of humor in it, actually held a bake sale, I believe, and they had cupcakes and
that was
games
Alan
and,
Stern. Yeah.
Yes.
Yeah, I was actually there at the one over at La Cañada High School, and it was a lot of fun.
Miles O'Brien's got to go. So again, what
I had
what
a great
treat
time.
to have you, Miles, and thanks for bringing all of your sort of deep experience in space landings and launches to this.
Not so much.
It was great. You brought us all up a notch in the level of journalism, so I really appreciate it.
It was a ton of fun. Thanks a lot for having me aboard, Fraser, and thanks to all of you.
All right.
Thanks, Miles.
Oh, what are you working on next? Can you tell us what you're working on?
I'm doing a piece on sleep for the NewsHour. So, but now that MSL is on the ground, years ago, Aaron Brown's producer came to me and said, we want to do a story. This is when Spirit and Opportunity were relatively new on the surface. We want to do a story on CNN in 3D, which made no sense at the time. He said, I said, well, how are people going to get the glasses? He said, well, we'll let them figure that out. And so we shot an entire story in blue-red anaglyph and put it on CNN. But now I think you could do a reasonably good, once we get a few images in, reasonably good 3D story with the stuff that's going to come down from Curiosity. So I'm going to work on that one.
How will people get the glasses?
Well, these days people have them. There's
they'll
more
figure
like
it out.
they're more. It's more out there. I mean, and they have 16:9 HD TVs, and a lot of things have changed since 2004. So
there you go.
Anyway,
Sawyer's going to be
all right.
selling them. Phil and Sawyer are going to go into business together selling 3D glasses.
There you go. Sawyer.
These are
Sawyer
actual
can
official
help me
NASA
out.
education ones.
Oh, there we go.
Sawyer can take care of it for us. No problem. All right.
All right. We'll see you later, Miles. Thanks again.
All right. See you. Take
No
care.
pressure
Bye-bye.
on my part. Good to see you.
No. See ya.
I keep inviting Nicole into this hangout, and she keeps not showing up.
Yeah, she keeps tweeting me and
Oh,
blowing me up
is
for it.
she on a cell phone that won't let her by some chance?
Well, that was the problem Will Wheaton was having. He couldn't get his phone to accept the
She's on an
invitation.
iPad. Do iPads allow Hangouts on air?
No, it's a mobile device.
That is a mobile
Oh,
device.
crud.
Yeah. She
Nicole,
is a
we're
computer.
sorry. You should have taken your laptop.
We still love you, though.
We do. We really, really do.
Apparently,
For those-
Pamela, you have an avatar in Second Life.
I do.
What is the name of your avatar?
It's Pamela Gondwana, because that's what it is.
Right. Isn't that the name of the merged continents?
Yes, it's
Yeah.
so when you sign up for Second Life, it gives you a choice of last names, and I thought a supercontinent made a perfectly reasonable last name.
So that's it. So in other words, Will Wheaton was going to join us, but because the mobile devices don't work in a Hangout on Air, he wasn't able to join us.
And same with noisy astronomer
Same with
Nicole
Nicole.
Gulucci.
I'm still hoping. I'm still hoping if we're still around in a couple of minutes, but
yeah,
I think we're winding down.
Well, the door's open, Will. It's right here.
Yeah.
Walk through it.
I sent him over there. He and his wife, but we'll see.
Well, I'm sure he would get mugged in an instant walking by those double doors.
Yeah.
Didn't he do the voice of that NASA introduction video to the Curiosity lander?
Yeah, one of the two videos. He narrated one, and William Shatner did the other.
Yeah. Cool. Yeah. Well, I think we're done. I mean, unfortunately, we now have to wait 8 hours for the next information to come from the Curiosity rover. So I think at this point we're just I was actually anticipating 90 minutes of pointless speculation.
Right. Yeah.
And
I'm
I
really
had
glad
set
we
that
didn't have
aside,
to
but
do
now we got absolute confirmation and photographs from the surface of Mars and the Curiosity rover. So we are done. I gotta say.
I can't believe we got the images already.
Writing a story about what I just experienced.
So where is everyone's next story going to appear?
I'm doing a photo retrospective of this whole weekend on Motherboard, including the bizarre Mars party from last night. So those, I've got a whole whack of pictures I'm going to put together. That's my big one that I'm...
Amy, what does your press pass say?
It says Credentials US. Actually, nobody has an affiliation on their...
Oh, really?
website.
Okay, well then you're free. You're scot-free.
So I don't really know what the deal is in terms of who I'm technically affiliated with and where these things have to come up. I hear they were.
His out.
Well, he's foreign.
I'm a foreign national.
I
You're
noticed
foreign
different
national.
colors and realized that it's green is NASA, yellow is U.S., and red is international.
These aren't Homeland Security colors, are they? I mean, red and yellow.
They actually at NASA facilities always red badge foreign nationals. So if you're even if you're a resident alien, you get red badged.
Yeah, when I was there for the shuttle launch, it was a really difficult time to get into into the Kennedy Space Center because I'm Canadian, and so everyone else was just zipping through, and we were, as Canadians, we weren't allowed to do a bunch of things that the Americans are allowed to do. So for example, we weren't allowed to go to certain areas within the facility without an escort. And it was crazy. So I had to keep asking for escorts to take me to various places at Kennedy Space Center.
Make sure you get the right kind of escort.
Yeah. And they just, and people just kept apologizing that they had to do this because as a Canadian, as a foreign national. But then Amy, you're Canadian too, so what's going on here?
My mom's from Maine, so I've actually had U.S. citizenship since I was 5 months old. So I'm a dual citizen, but because I was born in Canada, it does throw people off sometimes. I always bring my passport as my identification because you can't not have that if you're an American citizen. So yeah, I did still have to, when I did research at the NASA archives in Washington, I did have to wait 2 weeks for security clearance because I was born out of the country. But when I got there, it was really easy. I just had my passport, and they didn't give me any trouble.
There we go. Okay, well, why don't I wind this all down? So then, how can people find out more about everybody involved? Let's start with you, Amy. Where can people find out more? Did we lose Amy?
Oh, sorry, me. Hi. You can go to amyshirateitel.com, just my whole name.com. My blog, Vintage Space, is there, and you can get links to basically everywhere else. I'm at Discovery News, Ian, among others, and you can find all my stuff. And Google Plus, I do a lot out there because it's good people out there. So yeah.
Yeah.
Perfect. Dr. Pamela Gay, where can we find out more?
You can follow me at cosmoquest.org, where I will engage you in NASA citizen science projects and learning about this universe that we all share, and both Phil and Fraser are involved with that. And then I blog personally at starstrider.com. That has nothing to do with NASA, nothing to do with my university, SIUE. That's just me.
Dr. Phil Plate.
Oh, I'm just everywhere. Badastronomy.com will take you to my blog at Discover Magazine. I'm on Twitter as the Bad Astronomer, Google Plus, and just all that usual nonsense. It's easy enough.
Perfect. Sawyer, how can we find out more?
Best thing would be my Twitter is @theNASAMan, and you can find more about Talking Space and listen to all of our episodes. We took a break, but we're coming back this Wednesday with an interview at TalkingSpaceOnline.com. And I usually don't post that much to Google+, but you can find me there, and usually in person helping out with Challenger Centers for Space Science Education, as well as the Intrepid Sierra and Space Museum.
And I hope we'll see you again on the Weekly Space Hangout again at some point in the future. It was great to have you. So
looking forward to coming back.
And Scott.
I am the bald astronomer. So if you do a typo with Phil, you might get me. So bald astronomer on Twitter. My name, Scott Lewis, on Google+. I'm also getting going with my new website, knowthecosmos.com. And you can see us every Sunday night on the virtual star parties as well.
That's right. So now we replaced the virtual star party this week with our Curiosity coverage, but we're going to be doing another virtual star party next week, I guess exactly a week today. And then the next interesting thing that's going to happen now, Astronomy Cast and the Weekly Space Hangout are on hiatus right now, just because it's summer and we need a break. Not that we got one. But anyway, we're going to be back in September. The next big thing we're going to be doing is we're going to be doing a live show at DragonCon with me and with Pamela and with Phil, and I'm sure we'll have some other of our standard guests. And then we'll be putting that into the feed, and then come September we'll be running everything as normal. So. But you can watch us every week on the Virtual Star Party. This is where we hook up telescopes into a Google Plus Hangout and show you the night sky. So it's going to be really fun. So anyway, so for everybody here and for everyone who has come and gone from this Hangout, thank you very much for joining. I really appreciate everyone watching. Congratulations to NASA and for putting the Curiosity rover onto the surface of Mars and giving us the pictures and giving us confirmation so that we can, sleep knowing that it all came together. So thanks once again for sticking with us, and we'll see everyone at some point in the future. Bye, everybody.
Bye-bye.
Good night.
Bye. Thanks.
Good night. Thanks.